and then I use Stable Diffusion at the end. So my process was, when I started it, I asked ChatGPT to give me a Grasshopper script based off of Zaha Hadid or Frank Gehry building styles. I asked it 2 different prompts, and then I picked which one gave me the best results. From there, I then turned the script it gave me into the actual Grasshopper file. And then with that result, I then took it into an AI-based software. I used OpenAI, and then for the final, I'm going to use Stable Diffusion just because it'll give me a better result. I just didn't have the time to do that yet. So then I gave it both the picture of the model and a small text prompt with different architects as inspiration. And then the problems like we talked about last time I talked to you was that ChatGPT was giving me scripts that didn't necessarily exist. So I'm going to try using the Rhino extension, which is GHPT, which will, like, it's a plugin for Rhino that'll give me pretty much what ChatGPT does, but it'll actually be real Grasshopper scripts, hopefully. So with the ChatGPT part of it, I asked it to come up with a Grasshopper script that'll create a parametric building in a similar fashion to Zaha Hadid or Frank Gehry. And then it step by step gave me exactly what I needed to do and described what each thing will do. And then at the very end, it gave a breakdown. And I used this breakdown to create the script. The biggest thing with this one that I was running into was the divide domain 2 and the isotrim weren't working. So with the Grasshopper script, I got most of it to work, but then some of it was orange because it just didn't plug into anything that the ChatGPT gave me. But yeah, from there I got this, and then with this one, it's very like malleable, I'll say. Like I can keep adding curves and make this taller. And for the final, what I'm gonna do is I'll make it more of a skyscraper-esque, I think, just because I think it'll give me a cooler looking result. And then I'll also keep playing with the GHPT to come up with different scripts that might be better, and then I'll compare actual ChatGPT to the GHPT at the end. And then with the OpenAI, this using the picture above and then also using the prompt to make this into a building with a facade like Antoni Gaudi, this is what it gave me. And then another thing I think I'm going to do is I'm going to play with the abstractiveness of what I'm allowing it to do. So I'll have one where it'll conform more to the geometry I gave it, and then I'll have one where I'm letting it essentially do whatever it wants with the picture. But this is strength at 0.75. Same picture from above, but now with the Zaha Hadid facade. It took same strength for all 3 of the ones that I'm going to show. Again, I'm going to have one where it conforms more to my geometry, and then one where I'll let it do its own thing. I think this one turned out the best just because I think Zaha has more of a very like uniform style, whereas all of her buildings look the same. Whereas with Gaudi and with Gehry, they have more of all their buildings are slightly different styles. So it was having a harder time coming up with one full design. This is the Frank Gehry inspiration based off of it. I think this looks the most like his style, but it kind of took over my image. So for this one specifically, I think playing with the strength is gonna come up with wildly different results.
Good. A quick question. So the input image is lofted, right? That work. And then the text prompt will let them bring in different styles. Zaha's or Gary's. That's interesting. Would you like to talk a little bit about GHPT, right? Grasshopper PT? So what is the difference of that from GPT?
I haven't used it yet. I haven't had time to really get into that one yet, but from my knowledge, because it's an actual Rhino plugin, it speaks with Grasshopper actually, versus ChatGPT is just using the internet as its knowledge. So ChatGPT is looking at YouTube videos and like online websites, whereas GHPT is actually using Grasshopper.
I see. So when you use GPT, right, to ask questions related to grasshoppers, it gives you the instructions as a list, but you have to just read the name and then construct this spaghetti by yourself, right?
Yeah.
So for people who have very limited grasshopper knowledge, they will struggle to find the actual component based on the text name, right?
Yeah.
I see.
Yeah, which is also what I was running into, because like I know Grasshopper a little bit.
Yeah.
But with some of the ones, I was just having a hard time even figuring out like
translate.
Yeah.
Text to actual script.
Yeah.
Question?
I could use the GPT, so I don't know if they'll solve it. But if it doesn't, I recommend asking ChatGPT to just write code to do what you want to do. You can
Okay.
piece it right into a Grasshopper component.
Oh.
Like guide you step by step. But when it writes code, it has a much broader knowledge just based on the training that it had of how to write code to do these things.
And then I just make like a panel and like put the code.
I use Python just because I have a little bit of knowledge how to manipulate that. But there's another coding language that Grasshopper interprets.
Visual Basic. I also use Visual Basic.
Yeah.
I think that syntax-based scripting, right, Python or like, allow you to directly copy paste, so you don't have that kind of translation issue. But I don't know. I think that's something for people without Python.
I know ChatGPT is fairly decent at coming up with like actually functioning Python scripts, like other stuff like that. I mean, there's like Stack Overflow online, which is like a whole repertoire of coding information that it can steal from. So if you can find a way to make that work.
Okay. Yeah.
Maybe it's the time to learn Python. By the way, I think Grasshopper has a wonderful plugin called Iron Python, I believe. You can load in Python directly within Grasshopper. Yeah. Okay. Thank you.
Thank you.
Right. So let's move on to the next person. You know your order. Okay. Thank you. I don't have to.
Don't have to be right
now. It's now the mouse.
It's this one? Okay.
Okay. So,
oh, here we go.
Super small. Yeah.
Okay. Okay, so for the focus of my project, I was looking at Autodesk Forma. So the reason I chose Forma, it's an Autodesk product, so that means students actually get it for free. It's a cloud software, but there's also plugins for Rhino, Revit, and Dynamo, which I've never used, but figured I'd give that information. And it uses real-world calculations. So this first slide was just kind of for you guys. I found that you can import your own project into the site. So this is our Detroit site, and this is one of like my original designs that I imported in. And it'll do like some of the site analysis stuff that, you know, we do at the beginning of projects that can often get boring or tedious, and it'll do that for us. So for this project, I found that it actually does better with forms that are generated within the program rather than importing in. So I took 3 forms that were AI generated by the Forma AI generation, and it created these. I chose these 3 massing forms because they were very different in their layouts. And then I ran all of the analysis that it has to offer at the moment on that. And then I chose to compare those. So for the first option is sun hours. So this is like our daylight analysis that we always do. So it just sees how much, or evaluates the how much sunlight the site gets. And it'll do from whatever date that you want as well. So I did the summer equinox and then the winter equinox to compare. So this is the linear form, then the squares, and then the corners. Then this is the winter for each of them. Okay, and then the next is the daylight potential. And so what it does for this is it creates a sky component form, which determines whether a facade is receiving enough daylight for the interior spaces. So this is for the linear, the squares, and then the corners. And then the next one that I found was wind. It tells us the direction of the wind through a wind rose. And then it tells us the pedestrian comfort when doing different activities, such as sitting, standing, strolling, or walking, and then whether they would be uncomfortable in those spaces. So this is the linear, and you can kind of see like it gives the key down in the corner. So like sitting, it's uncomfortable. So here's the linear, squares, and then corners. And then next was microclimates. So it provides an estimate of temperatures on site and how comfortable a person would be. And this is I broke this down again into the summer and winter equinoxes. So here's the linear analysis. And here's the thermal comfort index. Here are these. Then squares, corners, and then here's like the summer. And then the next one, which I found kind of the most interesting because I feel like we don't really have a way to measure this, was the noise. It predicts the noise levels on the site. But something that does have to be inputted into this is the ADT, which is the average daily traffic, and that you can just find that online for the roads and railroads that are nearby. So this is for the linear, so you can see that there's a lot of sound down by here because we have that railroad track that runs right next to us. And then the squares, and then the corners. And then next was the solar energy. So this was an estimate of how much solar energy that could possibly be collected on site from the roofs. So here's the linear, the squares, and then the corners. And then the last one, which is still in the early stages of it, is the embodied carbon of it. And within this, you do have to put in some inputs of like what the program is, what the central wall section is, and what the framing system is. So for each of them, I just did a residential section or residential program, brick veneer, and then like wood frame. So and then this is the linear of the embodied carbon, the squares, and then the corners. And then my final slide is just a comparison of all of these. So I wanted to see them like all on one slide and see which one performs the best. And I was kind of surprised to see that the linear kind of was the best option for it because it did the best in the sun hours, the daylight potential, it produced the most solar energy, and it had the least average carbon. So that was kind of surprising. Whereas the square did better in the microclimate and then the noise. And the corners actually performed the worst in most of the categories. But they were all kind of right around each other, so it wasn't like a big jump from either. I think it would have been better if it was more into the city and had like different skyscrapers nearby, because then the like sun hours and daylight potential would have been much different, as well as the microclimate. So yeah, so revisions. And also another thing that I didn't think about until after was I wish I would have had like all of the AI forms be the exact same square footage or closer. And yeah, that's pretty much it. So I'll leave it at this side because this is kind of the most important snapshot of it.
Mm-hmm.
Yeah.
So you said that it doesn't handle like your own form input very well, and it handles the AI generated stuff better. How can you see like us like if we did an initial analysis of like the general forms being like linear, squares, corners, deal, how can you see like the transition from like that information like okay, like this linear form performs better to like actual design that is less restrictive into these like very simple geometry?
Okay, so just to back up to the beginning of your question, you can import and do the analysis. It just does better when the geometry is created in there. So you can import your geometry and then create your geometry on top of that.
Oh, so okay.
So it still does it. It's just I didn't think it performed as well because it's not capturing the like corners as best or essentially that. So you can still do it. But I think this is really meant for like an early design process. Like you're just doing iterations after iterations and like, hey, we have 3 iterations, which would perform the best for us if sustainability is a big aspect in the design.
I have a question. So for the linear, are you able to manipulate the height?
Yes.
To make them different?
Yep. Yeah, so you can change the height and the width of them, and it's pretty easy to do so. Like you can
like
add floors.
Thing.
Yeah.
AI generates information.
Yeah.
Then you manually
do
the points.
Yeah, I will say I did have some issues when doing this embodied carbon on the corners because it doesn't, if these are different heights, it doesn't like register that. So, and it won't do the calculations for you. So that, but this is like still in the beta stages of it. So I think they might resolve that as it becomes more popular. But yeah, that was an issue I found.
Another question. What are these tiny cylinder shape?
Yeah, so these are just trees that were generated by the AI. Unfortunately, their program doesn't take into account the vegetation yet. But I did.
When the solar daylight doesn't, it will ignore all the.
Yeah, it ignores all of that, as well as like with the noise, it doesn't take that into consideration yet.
And third question is, the wind simulation, daylight simulation. How long it take the AI to generate the design?
It was kind of different for each one. I think the linear was the fastest. The squares I think took a little longer because there's more. And then the corners wasn't too bad. But all of them, they have like, you can do a rapid analysis. So this is like a quick, like 30 seconds. Yeah, really quick. And it'll give you a general, and it's like a smaller scope too. But then the ones that I did were the in-depth analysis, and it says it can take like 2 to 20 minutes. I don't think any of mine took more than 10 minutes.
All right. Yeah, the reason I asked, in the technology field, simulation is very expensive, of course.
Yeah.
Especially related to dynamics, physics. And one applications in AI is use AI to actually learn the result of simulation and then produce the result instantly. I see if you run thousands of solar analysis in the typical building, then I understand the patterns and can do this without running the simulation. So I'm just wondering, curiosity on this software, if the simulation result you see now is actually produced by the simulation, or is just the AI generated, result?
Yeah, I'm not sure. Yeah.
But I know the second one I mentioned is in a very early stage.
Yeah.
Because people that may think about the regular form, like a box, linear corner is already enough training materials. But for the irregular shape, it's questionable. Yeah. But something maybe you can help me to dig into, see how the simulation works.
Yeah, I'm not sure.
AI is a part of this.
Yeah, I have to dig more into the articles that they provide with the like help.
Thank you.
Yeah.
Let's keep going. Who is the next person? All right, go ahead. Let's see. They close. in that corner.
Oh, yep. Sorry. All right. So my project is about exploring like how generative AI enhances architectural design innovation while also just keeping human creativity central. So generative AI creates new content by like analyzing patterns and data. Specifically for architecture, it can rapidly iterate designs based on parameters like sustainability, structural constraints, aesthetic goals. So tasks that typically take like weeks to develop manually. So I first started out just looking at like how generative AI does function. So I'm just going to do a very quick breakdown of it. So AI learns patterns from data sets, whether that's like thousands of floor plans, facades, or just anything you input into it. And then like a designer will input specific criteria into the AI, like spatial needs, for example, and then the AI generates tailored designs. And then after that, then you can like guide the AI outputs, so like iterating on the ideas to align with the creative vision that you have. So generative AI allows architects to explore design possibilities just faster and with greater precision. So it's good for like rapid ideation, sustainability, complex forms, adaptive architecture. To go like a little bit more into detail, it can create multiple variations in minutes. It can optimize for energy efficiency and eco-friendly materials. It can enable dynamic buildings that adjust to environmental changes like the Zaha Hadid architect's futuristic forms. And so while AI does exceed at speed and optimization, human designers, they're irreplaceable for their intuition, contextual understanding, and just emotional insight. So some of the AI strengths that they're good at, it's good at analyzing variables and generating efficient options. But some human strengths, there's interpreting cultural relevance and ensuring designs resonate with people. So like together, this collaboration would push design boundaries and create like innovative yet human-centered architecture. So for what I started looking into to test the interactive design, I used a kitchen renovation project I did a couple years back as a case study. I started out with Google Gemini. So I started with like very simple prompts, just design a 12 by 12 foot modern kitchen. And that first image is what it gave me. And then I started adding a lot more detail. Specifically, the client for this project wanted to keep her like yellow walls and like white cabinetry. So I was using that as a base. So yes, prompt 2, I just added more detail. And these are just other outputs I got with slightly different prompts each time. I then input the floor plan I had for it, still in Google Gemini, just to see what kind of 3D image it would give me, which it was not very accurate. And then I did try the same thing with Dolly, same prompts as before, starting out with the very simple prompts and then starting to go into more detail. And then again with the floor plan. So it struggled to like with accuracy and aligning to the floor plan and some of the prompts elements I gave it. This just kind of starts to highlight some of the strengths and limitations that at least these two AI tools have. But they're great for like ideation, but it requires human oversight for precision and contextual understanding. And then I also looked at key metrics. So to ensure AI augmented designs are both innovative and practical, there's a couple metrics that need to be looked at, like effectiveness. Does the design meet functional needs? Innovation, like how unique and forward-thinking is it? Alignment, does it achieve project goals like sustainability and cultural relevance? And kind of wrap up, generative AI is it's reshaping architecture by enhancing creativity, efficiency, so on. But it's not about replacing designers entirely. It's just kind of giving them more tools to help them in the process. So I think the future lies in the collaboration of the two. I think that's it.
One. The 2D right floor plan translation to 3D. You mentioned AI has struggled to understand the correlation between this.
Yeah, I mean, just because you can kind of see where some like the doors and appliances are, and it doesn't really match up with that in any way, shape, or form. The Google Gemini one, I would say, was a little closer. Like it had the window in the right place.
Yeah, this is really interesting. Just share with you, many years ago, we did a project to train the AI, understand the 2D floor. So you manually label window, drawers, right, based on the diagram, and then train the AI, and then AI will understand if you have this, curve, like a quarter of a circular shape, that means the swing of the door. So you need some kind of training.
Yeah.
Then it will successfully segment the drawings based on the meaning. The fridge is this shape, the window, the door, so they can precisely allocate space based on the diagram, and then translate into something. So I think in between, right, between the 2D floor plan and the 3D, seems like there's something you need to do it as a step.
Yeah.
In order to do the 3D one. I don't know what it is, but I assume the AI still not understand the curve, the swing of the.
Yeah, it definitely still struggles to understand what's going on in the floor plan.
But this is a really interesting experiment. Thank you. All right, great. Keep going. Just double check, make sure we recorded. I sometimes wanna make sure we are not missing any. Yeah, the recording is still going. All right. So who want to go next? Who is the next person? You. Okay. Also, if you are not able to present today, just make sure you let the next person know. Right? To say, I will go first. Wait, that should be fine. So for whoever not ready to present today, either we'll do it on Friday, or we come to you in another session.
Okay. Does that look fine up there?
Yeah.
Okay, cool. So yeah, like everyone else today, I'm doing another generative AI exploration. So kind of getting into the introduction of what I was looking at for the whole semester. Basically, for the assignment, I was focusing on using generative AI and learning about how to go the best way for using it and how different programs kind of relate to each other, like using ChatGPT to input text prompts into like things like OpenArt, VIZ3, and Stable Diffusion. Basically, my goal really was to use AI as a tool and start learning from that, and then seeing how I can incorporate it into Studio and then also elements within architecture. So basically, I started to play around with Stable Diffusion at the beginning of this whole process and had some problems doing the image to image, and also I think there were some things with potentially using the wrong LoRa's or checkpoints for what I was trying to use AI for. And so then I switched to OpenArt, and I had really good results just in terms of image generation. And so basically what I was using these two softwares, ChatGPT and OpenArt for, was looking at an analysis of ChatGPT, obviously an AI software providing you an architectural description of a specific building. So I gave it three or four different buildings and would use the text prompt and then put it into OpenArt and see what the outcome was, and then also compare it to the original existing building to the generated forms, and then see how the correlation between those two, and see like then analyze it further and looking at it in purpose of using it for studio or just like general architecture purposes. If you're working on a project and you know you want it to look like, say, the Barcelona Pavilion, you could provide descriptions or through this process figure out the best way to make your project look similar to it in terms of what is going on. Yeah, so the first one that I did was the Notre Dame. And basically, the whole process was obviously you need some form of human input to get an output from ChatGPT. And so a lot of my inputs were asking for the exterior of said project in a paragraph form with a longer description, just to get a more precise and accurate like analysis of the building. But also one thing that I did realize while doing this was, and you can see later on, when you mention the name of the project, AI is very easily able to interpret that. And so I kind of wanted to see the differences between the name that is put in and then also just the description. So this first one is the Notre Dame, and then just a general comparison between the two, which personally I think OpenArt did a pretty good job just with looking at it, and you can see the correlations between a lot of them have the three main portals of the Notre Dame. It has the two spires and the rose windows. So you can see a lot of correlations between these two, but kind of once you get into the more maybe contemporary or kind of like open-ended forms, AI didn't have the best interpretation of it until I added specific words. So this one was Aero Saarinen TWA Flight Center, and AI had a grasp of kind of getting the overall like fluidity of the project and materiality, but it didn't really get the overall form. So I think in terms of looking at it, if you want something similar to the TWA, you could use a description for what you have, but it's not a replica. And just another comparison, how you can see kind of the fluid form correlating between the generative and then also the existing building. And then this is the second exploration. And the only thing that I did for this one was just change the word in the ChatGPT generated description from structure to airport terminal. And once I added that, kind of giving a purpose to the building, OpenArt had a better understanding and getting closer to the TWA in terms of comparison, especially this bottom right image in terms of an elevation view in comparison to the TWA, it is very similar. So the next one I did was the Palace of Assembly by Le Corbusier, and I was again just looking at another kind of different form, looking at, or I guess style per se, because the Notre Dame is obviously a Gothic cathedral, and then TWA is a more fluid form, and then the Palace of Assembly is more kind of brutalist and kind of very orthogonal, and then just seeing how OpenArt interpreted that. So again, just comparison where it gets some aspects of it. A lot of these similarities come in terms of materiality and also just pulling some elements of it, but it can't really recreate the whole image or the whole building unless you're providing some more information like the name of it, the location, and other aspects. And then this was kind of a three-part study looking at the Barcelona Pavilion, which I did. I got a generated description that was smaller in terms of length, and it didn't really do the best job in terms of recreating it. And you can see in the comparison, I mean, it's somewhat similar, but not, I think, enough to where you'd say that these buildings are related. Then adding more context, you can kind of see the progression of it and see how it's getting a little bit closer to it. But again, there are some things that are missing where a lot of materiality is being missed. Then finally, once I added the actual name of the project, the Barcelona Pavilion, you can see that the output is a lot more consistent with what the existing project looks like. And so then after that, kind of just, I went into an analysis of looking at and understanding how you use this for moving forward. So obviously, like I said before, if you want to use it in a studio project, and these descriptions can be based off of the project, or once you start including specific things like the building usage and the building name, like if you're referencing, say, the Barcelona Pavilion in a project you're using, you can start to get a closer idea to what you want to like present and show. And so obviously I just realized that like AI had a very good understanding of the Gothic cathedral, and I think that's just because it's a very unique and there's very like prominent aspects of it. But then when you start to like move forward in time, a lot of similarities within the architectural forms like read through it, but they're not like very specific, I would say. So I think that's just the thing with AI, just learning. And I think another thing that I was thinking about was then looking into Stable Diffusion if there were LoRa's for specific buildings or specific architects. I think then that's another just aspect of getting closer to representing or re-representing the existing project. And then I think just moving forward for the end of this, I also want to get more into looking at architectural descriptions from like, I guess, professors or like an actual human versus just having an AI describe it and then comparing it in that sense, and then kind of creating like a guidebook almost, like, or like a if then statements like if you want something like this, use this and this. And I think just a description and comparison between the two.
So just to clarify the process, you mentioned the name of the architect or the name of the building, right?
Mm-hmm.
And then the GPT generated a detailed description.
Correct. Yeah.
Without mentioning the name.
Yeah. I was say I asked ChatGPT to not mention the name because I realized in some of the early studies that if you give it the name automatically, it has an easier time recreating it.
So when the art read the GPT script, it has no idea what is the architect's
Correct. Yeah.
original building you reference to. That's interesting. I think the translation from not sure it's the right term, taxonomy, how you describe the type, the construction, the material is very essential.
Yeah.
I wonder, with these really interesting explorations, the weight, right, of each category.
Yeah.
Which one you think has a significant influence on the result? Like material, some words relate to the material, some words with the construction type, or some words relate to, I don't know, lighting or the styles referencing to the historic time.
Yeah.
Do you have this kind of like breakdown maybe into different categories when you describe building? Some words associated with just material.
Yeah.
Some words related to structure.
Yeah. I say that is interesting because, like, again, the descriptions that ChatGPT is giving me is all of that.
Yeah.
Like what you're asking, it's like if one of those has more say. Like again, like if I'm changing
like mechanical.
Yeah, like like if I'm changing the name of it or like just certain words in my descriptions, then if I'm like changing other things like materiality and like seeing how
so
that
the result would be if you give this to another person, right?
Yeah.
Hey, in order to get a really good result from open art, here is our structure of description.
Yeah.
You start with this, then you start with this. Make sure you cover every single categories.
Yeah.
Then you guarantee you get something visible.
Mm-hmm.
Yeah, that would be something really interesting to discover. Okay. Very good. Thank you.
Thank you.
Okay, so let's keep going. Very good. Who's the next?
Reason mouse. No.
I've yet to see.
Oh, jeez. What's not his name nowadays? Does that present if I...
Give a minute. It's thinking.
There we go. All right, so I decided to go a little bit of a different route with my research because I have a little bit of a different background. I have a background in interiors, so I wanted to research something that I've personally used very infrequently, but still used to better my designs when I'm sourcing furniture for an interior. So I'm looking at identification and sourcing, how AI can ethically simplify the product procurement process. The objectives of this research is to determine if AI is a reliable tool in identifying products and their creators, to determine limits of AI in identifying products in varying environmental conditions, to establish prompts to allow for streamlining of procurement of identified items, to explore the future applications and ethical implications of AI as a tool to properly credit designers and artists, and then to discuss the limitations of AI as a tool to identify products and designers. So for my process, I'm using two softwares. I'm using ChatGPT as well as Google Lens, which that might change just as I do further research. But the first step of my process is to identify furniture. So for my baseline, I'm using furniture that I already know what it is and I know who's designed it or if it's a replica or not. So the first step of the process is to generate images of a known product. So what you see here is a vintage reproduction of the LC1 chair by Le Corbusier, Pierre Jeanneret, and Charlotte Perriand. Then I need to draft a prompt and utilize tools such as ChatGPT or Google Lens to properly identify the product in the images with as little assisting context as possible. So I've provided some example prompts here. In instances where the item is isolated, I've kept the descriptions of the item vague, so I'm not saying it's a chair or it's a table or whatever the item is. This is changed when it is an item that is within the context of a fully furnished space where I've asked it to identify the chair in the picture and seeing if it'll actually identify that. So then once I've prompted it, I'll continue to amend those prompts and images to determine parameters for proper identification. So just really quickly rolling through, I did 3 searches on the first chair with the prompts, identify this item, and then identify this chair in a context, and then I identify this chair in a separate context. So you'll see if I go back to this first image, the chair is in a different place than in the second image. In search 1, the item was successfully identified and additional context regarding the design of the chair was provided. In search 2, the item was unable to be identified without more details or markings, but design context was properly identified. And in search 3, the item was successfully identified and additional context regarding the design of the chair was provided. So the takeaway from this was the image in the middle is cropped off at the bottom. And so the images in which the item being searched needs to have it fully within the frame. The search is also capable of identifying the item with additional elements present. The second item that I've used is a recreation of the Herman Miller Eames lounge chair and ottoman. This one specifically is by Selig, produced between the 1960s and 1970s. So again, we're using images of properly identified products to search for possible vendors in this instance. So we've already identified the chair. Now we're going to go find vendors. We'll draft prompts and utilize tools such as ChatGPT and Google Lens to search for where the product or similar products can be obtained. And then I've provided some example prompts as well. And then we'll continue again to make prompts and images to determine parameters to obtain reliable, accurate sources. So again, we did a few searches here. This one is who makes this item? Find online listings for a similar item. Where can I find this item? So again, I kept it vague. I didn't say it was a chair or an ottoman. I just find the item for me. In first search, the item was successfully identified and original manufacturers provided, but it didn't give me specifics as to where I could procure that item from. So it gave me Herman Miller, it gave me Vitra, and then it said it might be a replica. So that doesn't really help me. Search 2, multiple manufacturers and vendors were provided, including a source for independent sellers, which you'll see at the bottom on Etsy. However, the search seems to place priority on mass market retailers over independent sellers. The first couple of retailers you can barely see there, they're all mass market, including Wayfair and some other manufacturers as well. Search 3 provided the original manufacturer, replica manufacturers, and secondhand and vintage marketplaces. So the quality and accuracy of the reproductions was also listed in the results, and the results still lacked independent furniture makers as an option. The takeaway from this was the language used in the search prompt will vary the results of the search. Tailoring is needed to reliably search for mass market retailers, independent sellers, and independent furniture makers. The overall quality of the sources listed is good based on personal experience with most of the sources listed. So most of these are vendors that I've previously used, which leads into a consideration that we'll touch on later. So how do I quantify the success of these searches? For product identification, I'm using the guidelines of, is the item successfully identified? What is the time spent taking and modifying images? What is the time spent taking and modifying prompts? And what's the accuracy of the results if the item is not completely identified? For sourcing, we're going to look at the number of results, the quality of the results, the accuracy to the reference photo, locality of results if it's criteria, time spent modifying prompts, and then the number of mass market independent sellers and independent designers and artists. Some other criteria I may consider if I'm looking for materials, if it's environmentally friendly or ethical, if that's something that I can actually search for, or if it'll just give me the same results regardless of me asking for it to be environmentally friendly. For procurement, if I'm asking for a carbon neutral or green company or a company that has fair labor practices, is it able to give me a kind of company like that? And for replicas, does it properly cite the original designer, artist, or manufacturer? And then I'm also curious to see if it has an ability to identify products created by POC, indigenous, or other marginalized individuals, or if it will be limited to quote unquote mainstream designers, aka old white dudes. One additional consideration, which is what I was getting at when I said that the previous vendors were vendors that I've used previously, is determine the amount of bias in results based on searches performed on specific account, and like my Google account, versus if I use an incognito mode or another browser that doesn't have all of those cookies still on it. Questions? Yes.
So yeah, definitely I remind me about whenever you lost password, the computer will ask you to prove be a human.
Mm-hmm.
And you'll give you a grade of pictures. You have to be free labor, right?
Yes.
Manual
yes.
tweak. So I can see the reason a lot of training free labor is actually going to maybe Google Lens.
Mm-hmm.
So do you see Google Lens has competitors who are doing the same thing?
I'm not familiar with any. I know there's a lot of stuff out there. I just haven't looked very far into it, but that's definitely something I could look into. I've been using ChatGPT too to put the image in and had it search the image like I had in the presentation. But it doesn't have Google Lens is specific in that you can have a full image and search the entire image, or you can zoom in, search an item, and it'll have little bubbles you can click on. I've even gotten it to zoom in even further on a sofa and been able to find the specific fabric that was used to upholster it. So that seems more unique to me in terms of the actual functionality of it, but that would be definitely something I can look into as to any sort of competition in that market.
Yeah, is that fair to say the image you're putting in the ChatGPT, right? The single furniture versus Google Lens, you have a collection of multiple objects.
Yeah.
So it's trying to classify, right, the image based on the meaning, multiple items. Is that the difference between these two?
I haven't run any. So for this presentation, I didn't run any of it through Google Lens, just because unfortunately I had some family matters last week that left me with a little bit less time than I expected. But that's another consideration, is I will be looking at it side by side to see what the difference is and what it kind of gives more of a quality result.
Yeah, I like the criteria. I think the result, depending if crop or missing a part of the furniture, or if the furniture is collaged with a few other exciting items, it will bring some challenge for the GPT.
Yeah, and one of the examples I had, when it was cropped and with other items, it gave me it kind of described it, but it's a completely wrong chair and the completely wrong designer. So I mean, that is once I changed it, it was better, but it's definitely, I'll have to search more into like what could be causing that or what other parameters would result in it coming up with an inaccurate result.
Yeah. It's also interesting to see, like in Google search, there is a manual way to manipulate the result based on how many people actually paid Google for their name.
Yeah. No, definitely.
However, for the ChatGPT, it's based on the general knowledge learned. There is a manipulation.
I think there definitely is with like sponsored content, and definitely a problem with it does have a bias that I can tell so far, where if I search Google myself for that item and then
pop up.
Right, or just like Wayfair. I don't want to see Wayfair. So how can I tailor that? That's the big thing, is how can I tailor that result so I'm not getting mass market producers, because I don't really necessarily want that. I'd rather use independent craftsmen or artists, whatever, but it's just, it definitely has a bias so far.
Great.
Thank you.
All right, let's move on to the next person.
I'm gonna close out of that.
Close. There's a close part. What? Thank you. All right. Yeah, come with me. No,
It's on here.
just
Okay. Okay. Is this good?
Yeah.
Okay. So for my project, I wanted to focus on the AI capabilities in architecture. So for my overview, I wanted to focus on how effectively and accurately AI can generate architectural designs with as little input as possible, or kind of like using the same input throughout the design process. I focused on using Stable Diffusion, and I wanted to see how well it could create floor plans, elevations, interior perspectives, and renderings. So for the first part of this, I wanted to see how well it could create an initial floor plan, and then taking that floor plan, how it could create other elements of design. So it kind of went from floor plan, and then I refined the floor plan, and then seeing if it could translate that floor plan into like an elevation of a building. So here it is. The first one is just a text to image prompt. So my prompt that kind of stayed the same throughout the whole project was floor plan of a house with a kitchen, family room, and then 2 bedrooms, 2 bathrooms. And then this first one was my first initial one, and it was like, it didn't really give much like direction of what was where. It kind of shows like that the kitchen is here, and you can kind of tell there's bathrooms back here, but you don't really know where everything else is. So then I put in an image to image prompt in Stable Diffusion, and I had a few ones of this, but this one was the one that came out the best, the second one here. And that one is a lot more refined. You can see it actually gets like the bedrooms and the living room and kitchen and kind of bathrooms back here. And then using this second image, I went and put that into Stable Diffusion and tried to create an elevation from it. And there were a lot of different iterations. Most of them just looked like floor plans. And every now and then I'd like change certain words and try to make it as close as I could to an elevation, but I wanted to keep it within as much as AI could do the project on its own, kind of. So this was honestly the best elevation I got of it, using the floor plan first. It kind of has elements of it. You can see that the windows and stuff, but it pretty much follows these these floor plan lines within it. And then I did the same thing, but I started with an elevation for the second one. So instead of starting with a floor plan, I wanted to start and see how it would work if I started with an elevation, and how it could translate an elevation into a floor plan.
So it's pretty good at, it is good at making the elevation. So this is the first elevation that it came up with. And then from that, I tried to create this. This is a floor plan it came up with after a few tries. And there's some elements of it that are similar, like it has like some like openings in the correct places. Like this isn't a garage door, but it has an opening there. And then it kind of has this like entrance. And then I think I actually did this one second. I might have them in the wrong order, but I did this one, then this one, and then had the floor plan, and it kind of takes a little bit of an element from the back, but not particularly well or anything like that. Then I wanted to see if it could kind of keep the same style in interior perspectives from the elevation, just because the elevation was the best kind of thing that I got. And every time I tried with a plan, it never really understood what I was giving it. So then I tried to do interiors, and it matched somewhat like the style of the windows and things like that on the inside. But there was no place that they like exactly lined up, but all the windows in this seem to be a similar style to what it would be in this. And then from Stable Diffusion, I wanted to create renderings of the interior perspectives and the elevations. And this is how it ended up. So the interior perspectives were so bad I didn't even include them because it was just like, it didn't really change anything of it. It didn't even like add color. And then for this, for the elevations, exterior views, it just kept changing too much. Instead of adding materials and just like giving it like cars and things like that, it completely changed the facade. So like this one was the first one that I put in here, and this is the image to image rendering of it, and it gave it some like context and things like that, but it like completely switched around where things were. You can tell that the elevation isn't the same. And then for the back elevation, it didn't at all. It took it as a front elevation and just changed the style of it, giving it this sloped roof. And so then I decided to try a different rendering, which is called Chrome AI. That one I just wanted to see its rendering capabilities and see how it was different from Stable Diffusion, and it gave me a lot more cohesive. All of them were in the same style. It kept very clearly the style of it and just added materials to it instead of changing things completely. One thing it didn't do that I kept asking for is it didn't like give me any cars or people, and Stable Diffusion didn't give me people either, like I asked it to, but it didn't give me exactly what I wanted, but it did do a really good job with the rendering aspect of it. And then just like takeaways from this so far is that like I wanted to see how much I could do within one site as Stable Diffusion, but at some point you kind of have to give a thoughtful approach to its application, like which AI you're going to use for what, like how this is helpful in here. And there's not really one full AI thing that can do everything. So, yeah.
Right. So when you use Stable Diffusion, did you use my server?
Yeah. Mm-hmm.
Okay. I think when you do the text prompt or image to image,
Mm-hmm.
I think image to image has a slider you are able to shift to control how much freedom.
Oh, okay.
Or you can make it really strict.
Okay.
The text prompt. I think that value is called code efficiency or denoising. One of these. Probably is denoising.
Okay.
So I wonder if maybe
if playing around with that.
expert,
Yeah.
experiment is to try different values
Mm-hmm.
in that kind of bar. Less freedom, more freedom.
Okay.
And see how Stable Diffusion is able to respond.
Yeah, I didn't even see that. That would be helpful because it kept changing so much in Stable Diffusion.
Yeah, refer to my tutorial there on Stable Diffusion.
Mm-hmm.
I think the default value is a 0.7 something.
Okay.
But I demoed if you push to 0.2, it's very strict. But to higher, you get a lot of hallucinations and
Okay.
freedoms. So play with these values. very useful.
Yeah, I will definitely do that for my final project.
All right.
That's
Thank
it.
you.
Thank you.
Which other time? Is this class an at 12:20? We could maybe do one more, one or two. Then for others, we'll shift to Friday. Where the next one? I'll use the laptop.
Okay, so what I'm researching is to generate triple periodic minimal surfaces through AI. Basically, I'm using ChatGPT to generate the trigonometric functional codes, which I can input in Grasshopper scripts and generate surfaces through that. Here is a basic methodology which I'm following, like asking ChatGPT to generate the functional codes. Trigonometric functional codes, and I have a standard script which is generated in Grasshopper with the help of Millipede and Beaverbird plugins. And what I'm doing is I'm just changing the yellow box which you see here with the functions generated by ChatGPT, and the right side is what I'll be analyzing. So moving further, all the basic functions of the math like sine, cos, and tan have those graphs which are shown here. They follow the specific wave pattern, and what I'm doing is I'm trying to analyze the wave pattern which are generated in my minimal surfaces so that I can get the specific kind of surfaces which I'm looking at and guide ChatGPT to give me the functions related to sine and cos to be specific, or sine and tan to be specific, or just the sine functions. Here is an example guide. Triple periodic TMPS basically has 9 basic surfaces, and I'm trying to generate the variance of that by jumbling the sine and cos functions. So what I've asked ChatGPT is to give me the permutation and combinations of the already developed triple periodic minimal surface by jumbling those functions together, and here are the results. I analyzed it here, where the left side is just using the sine functions, just the cos functions, and the results which I got here, what is the analysis is when I input the tan functions with any of the sine or cos, it gives me the inorganic forms. They are periodic. They are periodic in sense that if I'll put an STL file on the 3D printer, it would print a continuous surface, but they won't be organic. Inorganic. They would not be symmetrical. Here are some of the variants. Like what happens. The left side is a symmetric form, the original guided form, and the right side is the functions, the isometric functions which I'm plugging in, like changing the coefficient value of the y. Basically, x, y, and z are the axes in which the form further develops, and I'm adding a variant of either doubling up the surface in x-axis or y or z-axis. Here I am using cos and tan together and seeing what asymmetric surfaces I'm getting, and here are just adding different coefficient values. Like this is symmetrically asymmetrical, where all of the coefficient values, for example, 2 is added in all of the direction. Still, I'm getting an asymmetric surface, and here I'm using different variables such as 2 for x-axis, 3 for y, and 5 for z, and still I'm getting the inorganic variance. This is the other software. It's a free app which I'm using. It is called MS Lattice. It basically has 3 functions. One is the uniform lattices, functional TMPS grading, and the implicit function. For the inorganic forms which I want to generate, I'll be using the implicit functions, but here is just an overview of what it can generate. You can play with the size, the thicknesses, the modules, the basic module of the TMPS surfaces. And you can also change the thickness, which you can see here on the second image, that the base has the thicker surfaces, and it goes on reducing while you move on the top. Left is the cell grading, where the top cell is like 2, and the bottom cells goes on increasing in the variations. The right side, where the implicit function, I'm trying to add the again the functions generated to ChatGPT here, and changing the value of the ISO values functions. Basically, TMPS are generated with the functions which have a mean curvature 0, but this software also gives me an option of changing that ISO value to like 0.5, 0.1, or 0.7, and here is what I'm getting the results. Like if I do that, I change the mean curvature from 0 to 1. Basically, it changes the thickness of the solid form which is generated. And ChatGPT was not able to give me the ISO value function 1, because basically it is not actually a triple periodic minimal surfaces, because it is not continuous, which can't be printed. So ChatGPT only gives the functions which have a mean curvature to 0. Here are further options which I have tried again through ChatGPT, and changing the basic of trigonometric functions. Yeah.
Go back to one of the slides, which has a gradient change. Keep going. Yes, yeah. So number one, this is very exciting. I like it. If you guys actually search my website, right, VIZ3, and go to sculpture, you will see some sculpture I made exactly like fashion. That was done probably 15 years ago with all the, there's a program called MATLAB, it's an engineer program. You can write equations, then you generate forms. But this is something similar like this. You can check it out. I think ChatGPT, but there was no AI then. So I just want to confirm ChatGPT is able to suggest functions or equations for you based on some image you provided, or based on what?
No, basically it recognizes the triple periodic minimal surfaces, and it will only generate the surfaces, the equations which have a mean curvature to 0. So I can't just play anything, like I can't just enter sine and tan anywhere. It will only give me the functions which has to be 0.
Sure. So you have some input parameters.
Yeah.
It produced. Yeah, I would love to see if you can do a video capture sense.
Okay.
Awesome. So the reason I want to point to this image, I think this is really awesome. The previous one in ChatGPT with Grasshopper, you got things like very tedious, repetitive cells, right? But this one, there's a gradient change. So would you like to talk a little bit how this is achieved? So there is definitely more opacity one side, more transparency on the other side. So how this equation or function influence this gradient change?
Basically, this is just a gyroid form, which is the basic TMPS form, and as you can see here, there is a scroll down options of like 8 standard surfaces which are generated there. It would be interesting if I can use the implicit function and do this.
I was working on SketchUp Diffusion AI, which is a tool from SketchUp. It is a generative AI tool integrated directly into SketchUp. It allows users to create stylized images of 3D models by simply providing text prompts. These text prompts then diffuse the information throughout the 3D geometry and create an image from AI. How it works. So SketchUp Diffusion AI employs a technique known as text-to-image diffusion. The AI model starts by processing your text prompt. It breaks down words and phrases into numerical representation that the model can understand. And then the diffusion process is basically because it gradually spreads information from the text prompt throughout the image. After many iterations, the noise is transformed into a coherent image that closely matches the description of the text prompt. So this is what the tool looks like in SketchUp. The top is the description box, and then there's a styles box, a settings box, and then there's the rendered view. So for this one, I was doing the Farnsworth house just in a controlled view. Basically, I just wanted to take a 2-point perspective and kind of show that. So the styles overview, it comes with a total of 9 different styles to choose from. I'm just going to be showing you 5 for now. So exterior photorealistic, basically it comes with a pre-suggested prompt. So I'm going to use the pre-suggested prompt. So that's the starting image. After you click generate, the user is prompted with 3 AI choices with different materials and settings. So this is what the first one came out with, which is exterior photorealistic. It's pretty interesting. The next one was interior photorealistic, so it's good for interior renders as well. And it basically took it and made it seem like it was in a kitchen or a living room, which was interesting. It turned it into a piece of furniture.
Sure. The lighting generated by AI?
Yes, all the lighting, everything that you see behind it is generated by AI except for the model itself. So for some reason, it was taking the floor plane and making it into a rug for that one, which was interesting. Another one it can do is aerial master plan, but I just kept it in the same view to see what it would generate. And that generated these 3 images, which were kind of interesting. It took some like city aerial views and kind of like placed it up on a plinth and gave it some different colors and textures. The next one is kind of like where it starts to get like more stylistic, and that's the pencil sketch one. So here's the controlled view again. And then it came out with these 3 images. And then the next one is watercolor, which is our last one. And it came out with these 3, which were quite nice. So how does this benefit you? So being able to produce photorealistic renderings in diverse styles could be beneficial for rapid prototyping and early stage visualization. Iterative feedback from clients can help refine the design based off of prompt inputs, and reduced manual effort allows the user to spend time on designs and not graphics. So I was kind of running into some issues. I'm not really good with AI, so I was wondering what sort of geometry should I try next, and what kind of prompts would you try? Would you try different prompts than what they give you? And how do you see 3D geometry being used in SketchUp Diffusion to AI? Like, do you see the benefit in being able to add like textures, or like you input the shape and then that's it?
Question for you.
Sure.
Compared to Midjourney, right, and
Yeah.
other AI tools, what is the benefit to run this within SketchUp?
I see it more as like, as of now, I see it more as like a stylized way of getting like renders of a 3D geometry without any like materials. I see it more as like a material selective kind of way than anything right now. Just because I'm inputting the shape, it doesn't really add other 3D geometry. It only adds lighting and textures. So it's like you're not getting those incoherent results where you have random things being added. It doesn't add random objects.
Yeah, that's something I think is quite essential. On one side, you have creativities from AI.
Mhm.
On the other side, you want to have a coherence to the original idea.
Yeah.
On text prompt, the challenge is the balance between these two. I think in the SketchUp or any 3D modeling program, or same thing can apply to the VIZ3. You have certain kind of control at the beginning.
Mhm.
Like it could be a 3D geometry sketch, but only allow AI to imagine within the boundaries. I think it's a little bit easier to get things started.
Yeah.
I was wondering, in SketchUp, you can easily add material, lighting, people, furniture, right?
Mhm.
I wonder what might be the most efficient way to adding this, okay?
Mhm.
And then let AI to kind of
Yeah.
deviate from the original material, but still maybe deviate from original lighting. But this will have some kind of control beyond just the geometry.
Mhm. Yeah, and it only controls, like, that's the one thing that I wish it had is, like, you have to set up the scene itself. So, like, with the controlled view, if I'm adding my entourage and adding, like, different things, it'll pick that up, but it won't recognize it as, like, entourage just yet. Only architectural elements at the moment.
I'm also thinking if you put a piece of sofa, right,
Mhm.
in SketchUp, does AI actually recognize it is a sofa and then just giving you a new styles, different type?
Yeah.
For you? I think that's another way to use SketchUp.
Mhm.
Is quickly assemble the 3D asset within your thing, but without worry about, you have to be consistent about the type of furniture.
Yeah.
Just let the AI know, hey, here is the table.
Mhm.
But you can imagine giving me a different type of.
Yeah. Thank you.
Cool. Thank you. Question? No, all good? Yeah.
I'll let you figure it out.
Quickly, general
General.
documents. Yeah, that's fine.
No. No. All right. So I was exploring uh sketch uh sketch to AI. Here I tried out a few different AI programs, and my initial sketch was a painting. So this first one I was using Art Breeder. So you can see the painting that I started off with, gave it a prompt, asked for entire walls, and I actually took quite a bit of adjusting. So that was one of them. I didn't quite like the results, so tried another one, Open Art, still the same painting, not getting quite what I wanted. Tried another one with Deep Dream, and yeah, it was just difficult getting exactly what I wanted. Here's another one, VIZ3. So I decided to kind of switch uh, I wanted to use one of the collages that I had made and see what I got. And so the collage started off with the painting, and then I just took pictures of my model that I had built, collaged it in there with some perspectives, and the result was better. But I feel like I started to get away from the sketch, this generative sketch. So I went back
and tried to just define those hard lines again, because that's what AI uses, or that's what the uh, generative sketch uses, are the hard lines. So I tried to define those a little bit more, and yeah, they interpreted them as tiles and not tires. I'm still playing around with it. But I went back and tried to just simplify it with just a simple wall perspective and give it the tires prompt. This was the result, still not quite what I wanted, but I started to get closer once I kind of got more detail with my sketch. And I just took a part of my wall because I didn't want to resketch the whole thing and put that much detail in. And yeah, I mean, and the results are much better, here. And I see that it'll probably take it would just take me, it would just take for me to sketch the whole thing and just have detailed, well, not even too detailed, but just harder lines, a little more guidelines for AI to read and go off of. So yeah. So I don't think the painting is where it's at. You really need to sketch it and define those hard lines.
Do you have a text prompt with it?
I didn't write down my text prompts. They're in the history. Rubber tire. Yeah. I gave it a rubber tire prompt in.
So what is the media of the one you showed earlier?
The medium?
Yeah.
This is acrylic. Just acrylic on canvas. Acrylic on canvas. And yeah, I mean, they tried. They tried. And then just really learning how to go in and adjust specific parts and just speaking to AI to get exactly what I want. It's just a bit of a learning curve.
This is a prompt engineer type of work. Write text prompt. I think the one it will go down. Keep going. I like the one, actually, the next one. Yeah, actually, I like this one. I think this line work has been translated pretty successfully into it. But it looks like a break. Right?
Yeah.
Rather than a tire.
Right.
I think because the training probably is never noticed a wall with tires.
Right.
So breaks.
Mm-hmm.
This is interesting. You might also try Midjourney. I think Midjourney sometimes you require a more direct, honest consistency.
Okay.
Text prompt.
Okay. I had used Midjourney before, but I really want to try these other programs, but I'll go back to it.
But also, I think the collage, right? Picture of the scheme model, overlay quickly in Photoshop. Is it done in Photoshop, the collage?
The collage was done in Photoshop.
There's a AI tool as well.
Yeah, it is. There is.
That's fine. There's a tool called generative field. That actually is pretty smart.
Yeah.
You can define a region, then you will give a text prompt, give a field pixels based on a text prompt. I think that is a little bit like intent, right? In an image to image diffusion. But in Photoshop, because you have precise control on the region, you probably can easier get things.
Yeah. And with that, I had tried generative fill, but just on the like on a painting, just a blank painting like this, and it couldn't read it because it didn't understand. It didn't have anything real, I think, to go off of or anything like, I don't know. But once I put like a few like people in there, or even having these tires in there, then the results got a little better. It's not in this slide, but I've tried it before.
You need to give a little bit more clue, like about the scale
Mm-hmm.
of my theory.
All right.
Interesting work. I like it.
Thank you. Thank you.
All right. Cool. Thank you. Yeah, let's keep going. Now, who else is I used the one.
Oh, okay. Okay. So I was testing different generative AI softwares, and seeing how different inputs will impact the renderings that it gives me. So a brief history is that AI has been around since the 50s, and the early systems were rule-based, and they were looking for patterns that simulated the thinking of people in our decision making. And then that led to generative AI, and that means that it creates entirely new content, such as images, text, and designs from minimal user input. And these were the first chat boxes. And they learn from patterns from previous inputs and existing data to generate new outcomes that reflect the complexity and creativity of the original data. So I was mostly interested in how AI can be used as a tool in the design process in architecture, all the way from the conceptual stage to the finished product. And so my initial questions kind of started as, like, does a sketch drawing prompt have a lesser chance of becoming a more finalized looking rendering than a hardline perspective would be? And can a party diagram be used as a prompt just as effectively as a three-dimensional physical model? And this would all be among the same project. So I decided to experiment with different AI systems and to test these things. And so my ultimate research question was, how does the type of medium that is put into AI impact the quality of detail and style of renderings it produces? And the breakdown of this question would be, does AI respond differently to various inputs, such as sketches, models, diagrams, etc.? Does the style and quality of detail of the outcomes differ based on the medium provided? And are the outputs cohesive per project and look like they all came from the same project? So my inputs are sketches, hardline perspectives, physical models, party diagrams, and written descriptions. And I decided to test it with Midjourney, Chrome, AI, and Stable Diffusion. And then my process is to generate 2 to 4 renderings from each input for all 3 AI softwares. And then quality can be based on detail, color, photo depth, material usage, and style is how cohesive and stylistically consistent are the outputs with the inputs. And this will be with 3 different projects. I am only showing one today, and it will be tested with the 5 inputs, and then I will compare them. So the project I'm showing is Sydney Opera House, and my written input is all the same throughout the entire thing. And it's daytime photorealistic rendering of a waterfront modern building made with parametric concrete. And this is the input party diagram that I use for this one. And so Midjourney took the sketchiness and colors basically from that and created these. And then this didn't take any of the color or sketchiness. And then Stable Diffusion kind of only took the color and sketchiness. And then same with this one. Same output vibes as the first party.
Who did the sketch?
I forget his name. John, the architect. John.
Architect Origins?
Yes. And then elevation. Midjourney took the style from the elevation and kept the line weights in it as well, and then kind of made it more photorealistic in its own style. And then Chrome didn't take any of those things and made it all photorealistic based on the written input. And then Stable Diffusion has 0 evidence of the elevation in form.
And then here's a perspective also from the architect. All these are from the original architects. And so as we're going through these, you can see a pattern of the three AIs doing the same thing based on the input that is given. And then this is a digital model view, which was not from the architect.
This is the depths. If you go back to the dark color closer to the panel.
And then a view of a physical model. And so the observations made from all of that is that Midjourney tends to keep hints of the prompt image's style and its outcomes, and the colors, materials, position, line weights of the input image are similar to the output. And there's a pretty clear relationship between the forms and position in the prompt images and the output images. They're not the same, but they are similar. So I wouldn't say that the outcomes would be classified as a direct rendering as the input. And then Chrome images style is not evident in the outcomes because the colors and materials and line weights from the input images are not showing to have any impact on the rendering, but there's a very clear relationship between the forms and position in the prompt images and the output images. It's almost the exact positioning and shapes from the input images, and the outcome I would say would be classified as a direct rendering as the input. And then Stable Diffusion, everything was very inconsistent. It tended to keep the colors from the prompt, but the materials and line weights and positions are very inconsistent based on the input. And then there is no relationship at all between the forms in the prompt images and the output. So in my opinion, Midjourney would be the best generative AI option if you're wanting to explore ideas within the same style and similar form as your prompt. And then Chrome AI would be the best generative AI option if you're wanting to directly render your prompt and then add materiality and context with it. And then Stable Diffusion, I would not use it for rendering.
Questions? I like the way you formed the research questions as a pretty straightforward way to evaluate and conclude your observations. I think that is a really good example. If you guys want to be trained writing, you should think about this kind of logic. Questions, conclusions. I think definitely prompt AI is like the winner in this contest. Yeah, I think Stable Diffusion, there's a lot of controls. It's not as straightforward like the other two. You have to tweak a lot. And I think the image to image works better in my exercise. Text to image is very unpredictable. I agree with you on that.
Thank you.
Right, going. The next person. If I have someone skip the presentation, I'm not sure. Okay. Who is on the list now for AI? Okay. Are you also in the AI book? So how about whose name is on the front? Whose name is earlier upper on the row? You go ahead. And then you will be next. And who else on the AI besides 2, 3? So you will be the third one. Okay, so that's all AI. Cool. All right. Good. Do you want to switch to your own laptop?
Yeah, because I didn't know the slides and I didn't have it.
That's okay. You can unplug that. Listen. Yep. Have HDMI.
Yes.
Sure.
All right. So for me, I wanted to create organic forms. And sorry. So the mobile scripts was the idea or concept I came with to create organic form Peruvian styles using Grasshopper, Midjourney, and Rhino. So here's just an overview of my insights and just explaining the form itself is a continuous surface. It has one continuous surface and one continuous edge, the mobile strip, and it's also known to symbolize unity and infinity. So this is my overall objectives for this concept. I wanted to create spatial interactions. I also wanted to create a mathematical index system using Grasshopper and using specific parametrics such as like indices, factor numbers, points on the curves, signs, and twist counts. And then manipulating them and changing them and keeping some specific parametrics constants and then also changing numbers. So here's my Grasshopper scripts, and then these are the callouts of the specific 4 parametrics that I played with in Grasshopper. And then these are the outcomes of each. So I changed the factor numbers. So this is factor 3 on the same constant number and indices and the points on the curve. And then as I continued to change the factor, it became more sophisticated or complicated, or it had more twist counts. And here's some front elevations of these forms. And then I did some artic views of the form as well. So for Midjourney, I started off by inserting the image into Midjourney and then giving it a prompt of how I want the form to look like. And this is the first outcome. And then I changed the prompt to render the image instead of just to get a different look of the space, and also adding specific detailing such as pathways, integration with scenery, atmosphere, and then placing people within and also mimicking this nature in general. And this was the third analysis that came up with. And on Midjourney, there are specific functions where you can upscale, you can rerun, you can create, you can make the image more creative, or you can make it strong. So from this image, I just upscaled it, and this is the outcome of this.
Sorry to interrupt. I forgot to ask you to share your screen. Are you able to join Teams and share your screen? So I will get the recording. Yeah, just go to this way. See the meeting join. Okay. Right. And here. Okay. 1 minute. Actually, you can mute because we are recording the sound there anyway.
Okay.
And then go to chat. Go ahead. Yeah, now you can continue. I just want to get it recorded.
Okay. So then this image is the upscale of the second analysis that I did. Okay. And then for this fourth analysis, I just made it more stronger and also added more detailing like greenery and also just interaction with the space. So like more open spaces and then people within as well. And this is another prompt where I just went more specific and then made it more photorealistically. And then I also wanted to create like a more functional space and have like more purpose to it. So then I made it like an event center, or I gave the prompt to be an event center, having various programming such as cafe, restaurant spaces, exhibition spaces in a grand central hall, and then just having natural light filtrate the whole entire space, and then also still connecting with the nature, with the natural environment as well. So this is what I came up with. This is what it developed, and I upscaled. I rerun it and I made it stronger. And then here are just, to add to the prompts, I just wanted some vinaigrettes of like the various activities happening within the image. And then this is what it created, just showing me different things going on, seating areas, and then just smaller, I guess, interactive rooms.
Very cool. So in Midjourney, you take the text prompt in as well as in the renderings, like image screenshot from final. But definitely, I think the result is different. I already moved away from the original form. How do you think this, deviation? This might not be the moon wheels anymore. Are you happy with this way? Planning to train and then creativity?
I think it's slightly deviated. However, it still has the attributes or the form. Like, it still has that twist. I can still see it. I would say it deviated. Maybe just made it followed the president and then changed it into something different. I also still see the organic form nature that I wanted to show as well. And yeah, I still think this definitely still has the attributes of.
Yeah. So yeah, I think these renderings are nice about it. The way this is Midjourney, right?
Yes.
I think Midjourney has a really good understanding of lighting and material. It's kind of polished, reflective surface with really brittle.
Yeah, I specifically also in the prompts made it translucent material. Like, I specifically told it to make it translucent material.
And also you did the flat.
Yeah, I did the reflex.
Upscale.
Yeah, that's good.
The press. Oh. Next question is how to build it.
Yeah.
Okay. Thank you. You can stop sharing. All right, so let's keep going. Yeah, so the recording is still going on. You want to go ahead? Let's see my mouse here. Yeah, that's it.
Is there a full screen?
Not really.
Okay, that's all right. So, for my project, I wanted to train a version of the AI that can recreate kind of the drawings of this architect Alvaro Siza. This is kind of one of his. So, to do this, I went with Stable Diffusion. It's kind of the only option if you want this level of control over what you're trying to do. For the first, step, in training this AI, you have to collect a ton of images. So I went through Google Images, I found a book, I scanned some photos. All in all, I think I collected 75 different drawings. However, when I actually trained the final model, I only used about 30 of them. So here's a couple of them. He's got a very kind of distinct drawing style where there's a lot of detail, but it's also very loose line work. You can see people, especially right here, kind of mostly like a squiggle and kind of the shape of a person, but it's very recognizable. And I really enjoy his style, which is why I tried to create this AI to do it. So first step of the process, after you collected everything, you have to resize and scale everything down to exactly the same resolution. So in most cases, this is pretty easy. With this image, you can fit the whole thing into a square 1024 by 1024 image. In other cases like this one, the image itself doesn't fit well, right? If you wanted to make this and include all of the image in your little, square new image, it'd get very small. You'd end up with a lot of white spaces on the sides, and you want to avoid that. You want your picture to take up the full space. Otherwise, the AI is going to learn that and start putting white space on the sides of its images. So after this, you have to take all the images and run them through a tagging program, which goes through and it's an AI itself that goes through and it analyzes the images and kind of figures out what they're about. And in this program, I went in and manually added the Alvaro Siza tag, right? So it can pick up certain tags, but you want to include other ones that you can always call them out and say, no, every time you include Alvaro Siza in your description, it knows to look at this kind of stuff. After this, there's a big training process. You plug it in. I first ran with all 75 images. It took basically a full weekend to train the AI. And as you can see, it worked great. No problems at all. Perfect result. So I retrained it again with, less than half of them. I think I went with like 32. And you actually get pretty good results this time. It kind of carries through a lot of the elements of his style, right? This is just a text image asking for, a building. You can see kind of the loose lines, lots of this really kind of like squiggly shapes that fill in the dark areas. But there are kind of like a few problems with this, right? When you train an AI, you're really making a modification to an existing model. So, you have to make sure that the AI you're doing is what's creating this image rather than just the existing model doing it all on its own. So because I'm using Stable Diffusion and have that level of control, I can tone the power of my AI version, the LoRa, down. So, also because you have Stable Diffusion, you can recreate the same image exactly each time and only adjust one variable. So keeping everything the same and turning, my LoRa off, you get this. So this is kind of like the base image that Stable Diffusion wanted to make before I changed it. So this is at 0 strength, and then you can kind of see as you start toning it up. So this is at 1/4 strength. It starts to get a little looser, a little sloppier. Half strength, once again, changing a little more. 75%, it's starting to look more like the final product. Full strength, you're getting really close. And then I actually cranked it up to 1.3 to get the version that I like the most, that I feel like was most representative. Now, the other thing you'll notice is it also starts to get kind of a yellower background the more you do it. And there was no way to get rid of this. So, right, you can prompt it, you can tell it to, have a white background. But the problem is some of the images I trained on were photocopies of an old book, and they had a, yellowed page background. So, the more I say, be like Alvaro Siza, the more it thinks that means also have a yellow background. So, the way you fix this is I would go in and change the images I trained on either to not include those ones, or I could just open them in Photoshop and color correct them to, appear like everything else. So, but this is all just kind of the text image, which really isn't what I wanted to make the model for. I mean, I think it does a pretty good job, but I really wanted to take my images and plug them into and allow this to kind of change them and modify them. So that's what I went with. First time I just took a basic render, and you can see the starting image and the ending image, which the ending image does pick up some elements of his work, right? You can see kind of a lot of these squiggly lines and stuff, and it's kind of nice, but the base image simply has too much color in it for it to accurately make a black and white image. And if you kind of adjust the settings so that you get enough freedom for the AI to convert the whole image to black and white, you completely lose all concept of what the original was. So then I thought, hey, let's take a black and white, just kind of shaded image. And once again, kind of interesting. It works a little better. I really do like the people in this. I think they look a lot like Alvaro Siza people. But he also didn't really shade his work, right? He kind of kept things just lines. And once again, this really wants to shade. And if you kind of get rid of the shading and just do line work, you start to lose what the actual image is about. So then I figured, well, I'll just plug in line work. And it starts to work, right? Some things like the people turn out really well again, but now part of the problem is these lines are really nice, sharp, and crisp. And he has, never has those kind of perfectly straight lines. And it's, again, one of those hurdles where you just kind of can't force it to break up the straight lines without also keeping it similar enough to the original image that you'd want to use it. So wait, oh, I'm going back and there we go. So then I thought, what I can kind of do is take all of these different versions of the AI image and kind of composite them together to make something new, which is, vaguely reminiscent of Alvaro Siza. And that's what I ended up doing in this, which, I think is kind of interesting. I don't know if I would use it in a presentation, but, it's the kind of photoshopped composite of all of the different AI versions of the space image. And that's the presentation.
I have two.
Mm-hmm.
First one, you mentioned attempt 1 and 2, right?
Yep.
One is already. What's the difference?
So I don't know. It's one of those things where, I put in all the settings that I think I need. I've got all the images selected. And then, you just kind of run it on a training program for like 2 days, and then you get an end result and it just doesn't work. And so then I just go back to the drawing board, like, let's clear everything out. Let's choose a smaller set of images. And I changed a few settings slightly, like I adjusted what like encoder it was using and what like the base model I was training on. But, AI is just kind of such a black box that a lot of this is like, you kind of take a guess at what you think will work, and sometimes it works and sometimes it doesn't. And I think I got unlucky with bad settings on the first one, and I got lucky with good settings on the second one.
Yeah, I would love to know what are those settings.
Yeah.
We write that in your paper.
Yeah.
I'm also wondering, this is based on the stable diffusion checkpoint.
Mm-hmm.
Make sure you mention that. And I would love to have your LoRa.
Yeah.
If you are okay to share that.
I am. I think I want to do another version that fixes the changing everything to yellow backgrounds.
Sure.
But I think that's pretty easy.
Yeah, that's good. Yeah. So now we have a way to put our customized models. That's important. Cool. Good work. Thank you.
Thanks.
We
Hello, today I'm going to be.
I just want to make sure I shared my screen.
Oh, yeah.
I probably already did. Just want to double check. Because I know sometimes when you switch. Oh, we didn't. Okay. That's all right. I think we probably didn't capture. Here's.
Hello, today I'm going to be talking about AI to 3D production and its uses in architectural design. So this is a description on how exactly AI has been developed in order to create 3D models. It uses stable diffusion instead of using and Stable Diffusion uses a collection of 2D images as its training data. Originally, when they first wanted to make AI 3D models, they decided, oh, what if we create training data based on a bunch of 3D models? The problem is 3D models take up a lot of storage, and there's not as many 3D models out there as there are images. So they decided to combine this with another AI program called NERF, which is used for to take photos of an object and convert that into a 3D model. And so by combining the text to image model, they combined it with NERF, and basically what the AI model will do is it will take your input image and try to create different photos of that image from different views and throw that into NERF to create a 3D mesh. This was my first testing. I used a program called Meshy AI. This had interesting outputs, but it's not as good as the next program I used, which was, and here's a Tripo AI. I have the wrong title, but this was Tripo AI, and these created better massing models, way more detailed, that I thought was good. And here's another one of this building. Now, how I think this can be incorporated into the design process in architecture is by creating massing models that architects can use to iterate and get ideas from before starting their final design of a building. For this experiment, I had the program create 3 different iterations based on the same input image. And for the study, I wanted to show if AI can create multiple massing models that can be used to figure out different possibilities on how to design the overall form of a building. And so for these 3 tests, the AI did a good job replicating the side of the building facade in the picture while creating very different back exteriors. And so as you can see from these 3 input images, it was able to replicate the front very well, but on the right images, the back side, you can see it creates 3 different forms. And I think for an architect who maybe hasn't fully decided how the form of the overall building will be, they can look at these and pick and choose which ideas they like for in their final design. The next stage was to 3D print AI models. I have them right here. And so the AI produced 3D models, I think, can aid architectural development in the brainstorming stage and create multiple iterations on a building. And so my idea is you can 3D print these and analyze them side by side as massing models, kind of like the 3 images on the bottom that I 3D printed. The main issue I found is that the models are not very clean and often have holes in them that need to be filled, or it won't be possible to 3D print. Luckily, these 2 models that I did print did not need that, and they were able to print cleanly, even if the bottom was not flat. But the 3D printer was still able to print them without any issues. So for conclusion, to round it all up, I think that I was successful in creating the early stages of a pipeline that future architects can use to create massing models in the early stages of design. By giving it an input image, the AI will copy the view it was given and create a complete model from all 360 views of it. By replicating the process, you could create multiple massing models of different possibilities and 3D print them. And by lining these prints up, you can choose which elements of each model you like and what's best for moving over to the next stage of design. And then just some questions that kind of popped up while I was making it. I was wondering how AI-generated massing models can influence the early stages and processes of architecture, and what the potential benefits and limitations of relying on AI is for conceptual ideation. And then the second question is, to what extent does AI-generated massing models save time on the design process? So thank you.
Any questions? Yeah, I really enjoyed to see the process you have chosen to have AI generate a three-dimensional form and then be able to materialize to fabrication. And I'm also thinking this in a larger scale, as you tested the digital fabrication process, if the AI can fabricate, right, not necessarily the massive model, but pieces of the building. Let's say the shading devices, right, or some panel form. I think that will be a derived from AI to real size architectural component. That could be automation. Very cool. I like it.
Thank you.
Yeah. All right. Good job. Is there anyone else from the AI group want to present today? All right. If so, I think we can move on to the digital heritage group. It always takes a bit longer time, but I think today we can at least get some of you. So let's, based on the order in the Excel, who are the first one in the digital heritage group? Are you? Okay. So why not? Let's start that group.
Where are the rest of the folders? Oh, they're there.
It is,
It was just taking a second to load. So yeah, my digital heritage project was focusing on creating a digital museum. Laptop, not that one. Got it. Cool. It was trying to use LiDAR scanning and digital scanning apps to create detailed 3D models of significant artworks that would then be uploaded into metaverse virtual reality, such as hyperspace, to allow people from across the world to visit artworks they wouldn't typically have access to and discuss them with people they wouldn't typically get to meet. I evaluated the different scans I did based on if it was a complete capture, if it captured fine details, the smoothness of the model, and the lighting. Because I was scanning artworks in the Cincinnati Art Museum, I didn't have control over the lighting. So it's not like if it was too bright, I could adjust it. Can't call up the museum people and be like, hey, turn the lights down. So I scanned this angel statue, and it was mostly complete, except it was up against a wall, so the very back of the bottom wasn't complete, but everything else was pretty good. Artworks on the wall did not scan great. The apps were unable to figure out where the precise bounds were, because it was on a wall, and in the back obviously had a giant hole in it. Sculptures and pots scanned great, except for this smaller one in the center was sitting on a mirror, and that threw it all kinds of off. Didn't know what to do with that. But it could scan like whole exhibits, not just individual pieces. It was unaffected by anything in a glass case, which I was kind of shocked at because typically anything reflective doesn't work, but it had no problems. It captured fine details of ironwork sculptures very well, and all kinds of other stuff. it captured the lion on this really great, but not the pedestal it was on. And then where's my video? Yeah. Oh, cool. You gonna let me play it? You're not gonna let me play, are you?
Is this the link?
I placed it in my presentation, so it shouldn't be a link.
Copy paste. Probably it's a private.
Oh, that's weird. I didn't mean to do that.
That's okay. Do you have the link in PowerPoint?
I don't think so. Maybe I do. Oh, shit.
Yeah, later you can post the link.
I can post it. Yeah, it's just a little video of my little character walking through the virtual exhibit.
Is this on your...
It's not on YouTube. I just screen recorded it on my laptop, but it's gonna be like the final video we post is essentially gonna be a lot of me walking through the virtual museum that I've created. The only problem is I've had a hard time getting the texture to map right. Whenever I upload it, it uploads the solid color, not as the scanned texture.
This is on YouTube.
No, it's just a video I took of my, like a screen recorded my laptop screen.
Right.
But I haven't posted it on YouTube. It's embedded just from my laptop. Like, it's not on YouTube. It's just I placed it from my laptop. I'm not sure why it won't let me open it.
Just download.
Okay.
But I know sometimes the browser base makes all kinds of weird stuff.
I don't know how to get out of
just simply close it. So let's go to... Okay, just simply re-download the file. Okay, so go to your folder. Okay, so this time I will go ahead, download. So you like hyperspace?
Yeah, it worked great. It was the easiest to use, I think. Other than my texture mapping issue that I'm having, and I can't seem to figure out how to repair.
Okay. So let's see if that video works here. Oh, it's still not...
It's just a picture.
Yeah, it's not here local. It's embedded from OneDrive, but that's okay. Yeah. You can show us next class if you like.
Yeah, sure. Yeah, I can send it in the Teams, or I can show it next class. Yeah, that's it.
All right. What kind of device for scan?
What kind of what?
Is it the iPhone? Or...
Yeah. I just I've got the iPhone that has the LiDAR scanner, so I just use my phone.
What's the app name?
It's the Rhino app.
Rhino app.
It's Rhino's app, which is.
You mentioned that.
Oh yeah, I should put that. It's Rhino's app. It's free right now because I think they're still beta testing it. So.
I've got permission from the museum.
Technically, no.
That's okay. Yeah, that's okay.
I mean, you're allowed to take photos of artworks. I'm plagiarizing.
Yeah, I think the virtual museum is a really powerful way to allow people to actually experience the artifact without actually physically go there.
Yeah.
It's also a good application for the metaverse.
Yeah.
All right. In the future, please also invite the URL of this hyperspace.
Okay.
So we can all go there. We see each other as everyone.
Cool.
Let's do it in the next class.
Okay, can do.
Right. Yeah, just put a link to your hyperspace.
Yep. Sounds good. Cool.
Thank you. Great. Let's go in. What else in the digital paradigm? You are on the list. So yes. Go ahead. Think so. That's all I have. Okay.
For my digital heritage thread, I would use recap photo to create 3D object or 3D scene. Yeah. Recap photo is a software developed by Autodesk using the photogrammetry technique to generate 3D view or 3D objects from photos. And I would use it to generate 3D view or object or scene that relate to architecture. And the objects I choose for this presentation are a fire hydrant, the partial steps and partial column top in grand stair, and an interior stair steps. For the fire hydrant, I use these photos, around more than 20, and it can create this one. I mean, recap photo, it is able to create this one, a real object, and it has a video as well, but I don't put it here. And it can also create a random object, like the right the right bottom. I put it in my project in here like this, and because this is the small object, I would try other larger scene, so I choose grand stair, and this is the one I with these photos, it can create just part of the scene, and it is somehow successful or unsuccessful because it cannot create the whole scene that I want, but I mean, at least it can create part of it, and it's really real. Just the handrail here, it has some like mistake. It cannot create this part, and then just a small part like this, and it can create a rhino object with real mesh as well, but it's very thin and it looks not very nice. It is just a surface, a thin layer, which I don't show here. So, and I try another, I mean, another scene from Grand Stair, that is this set of photos, and it can also create just part of this one, of the top of the column. And I try to measure, because recap photo lets us to measure the distance from this point, between 2 points of the image it creates. So I try to measure from this point to this point, and it says 4 feet. But I think it's not correct, and I don't know, still have not yet figured out how to make it to the real dimension. I think from here, from this point to this point, it is just about 2 feet, but it measures 4 feet. So I'm still figure that out. Okay. And another one, I mean, I tried this steps because I thought with the large scenes like grand stair, it may be very large, and the recap photo just like to focus on small details. So I would choose a smaller one. That is this is stair in my house, and with just some like 20 photos, it can just focus on some steps only, and still cannot create the full stair as I want. And it is just that. And they are the successful thing I have done so far. I also have tried
other. And this is one of my failure. I tried my car and took photos of all aspects, and it can just do like this. And also the measurement is not correct. From this point to this point, it measures just 1 feet. And I don't know how. I am not able to figure that out right now. So, and other failure case that, right, with this collection of photos, it cannot generate anything. And it informs that my photos are not focused and they are not 60% overlap. Why I think that the photos I took here, they are like most of them 60% overlap, and I still don't know why. So after all, I think that the recap photo is not good at generate the scene with various large objects, and it seems like to focus on a detail in the scene, and it needs each photo overlap 60% the next one, and even we have the photo set which have all the photos that is 60% overlap with others. It cannot generate anything at all, or it just badly generated the things. And it needs the skill from the people to take photo and very focus on a detail, and we have to choose photos to put next to each other so that it can generate a successful scene or object. So that is my research right now. That's all.
So all of that is recap like all kinds of challenges.
Right.
So my project is looking at 3D reconstruction using 2D images, and I used a couple of techniques to try this, and my subject matter is the suka that our class built last year. The presentation today, I'm going to focus on Gaussian splatting. So here it is in PostShot, which is the program I use in my model. Fairly simple. I just loaded in images taken all the way around the suka. You can see the camera positions kind of making a circle around the suka. So that was something that the program was able to calculate using what's called structure from motion. So what's going on is it looks at each image, tries to find features that match between the images and patterns in these images that it can find locations of, and then it looks to see what is the difference in location of these features that it recognizes in multiple images, because a lot of the images have overlapping features. I'm only moving like a couple steps every time I take a picture. So it can calculate from that the positions of the cameras, and as well it'll calculate those points that it's recognizing in 3D space to make a sparse point cloud. Then what it does is it calculates these Gaussians, and I just want to walk through what exactly that means. So a 3D Gaussian is described by a multivariate normal distribution, which sounds kind of complicated, but it's pretty simple. Multivariate just means there's multiple variables. This is in three-dimensional space. And a normal distribution, I'm sure you guys are all familiar with. It's this bell curve. So in one dimension, it just looks like a bell. That's why it's called a bell curve, where it has a maximum value, it's mean, and then away from there, it gets closer and closer to zero. So if you think about that in 2 dimensions, you get like a ellipse. And then in 3 dimensions, you get an ellipsoid. So this would be like just defining like an outer boundary, but really these are continuous functions. So it gets denser denser as you get toward the mean point, which is somewhere in the very center of this blob, and then less and less dense as you go further away. And in the reconstruction, these are all those little Gaussian splats, and they look kind of like little sharks. A lot of them are a lot skinnier than that kind of more spherical looking ellipsoid I showed. And then what happens is it slowly optimizes where these Gaussians are. So they have a certain number of properties. They have their mean position, they have their shape, the size, the color, and the opacity at different lengths away from that mean point. And so by modeling all these Gaussians in three-dimensional space that are continuous, they start to overlap and form a finer and finer resolution image in the outputs. The way that that happens is it'll look at a calculated image using the Gaussians and then compare it to an image from the training set that's in that same position to say, does this look like the training data? If it doesn't, it'll tweak it just a bit, move those Gaussians, change their size, opacity, etc., and slowly tweak it using gradient descent until it gets to a specified threshold value. And that's something I was able to play with in the training data. I ran it a few times on my computer. Then as I increased that threshold and increased the resolution of the images I was putting in, Ming actually had to help me with his super powerful computer to calculate the model. But what's cool is once it's calculated and run on that local machine, he was able to send it to me and I can run it on my computer. And I'll run it here and show you guys a demo in just a second of what that looks like once it spits out the output. And for my specific research question, I was looking at the perforated geometry of the Suka, so all those slats, you have to kind of see through them to see what's in the middle. So here's an example where I used photogrammetry in Meshroom Atlas Vision. And you can see, didn't work that great. I mean, it's fairly impressive if you think about what's going on. So this is doing the same thing where it's calculating the camera positions based on the structure from motion algorithms. And what this does is it takes the point cloud, creates these meshes, so it's actual 3D geometry, and then maps on texture from the input images. But it really struggled with the perforated geometry of the Suka slats, and my main point of evaluation for all these techniques is to look at the table inside the Suka. And you can see in the photogrammetry model, the table's basically not even there. It's just kind of blobs. And then you compare that to the Gaussian splat model, looks a lot better. But what's really impressive about this technique, and I'll switch to the demo now,
Yes.
is the way
Tilt the camera a little bit so the camera can actually see the screen on your back.
is the way that you can start to look at. So I took all the pictures like this around the Suka, and this is probably the best view in terms of fidelity, capturing the input data, but you can actually go inside of the Suka. And obviously there weren't any pictures that were in here capturing these angles, but it's able to give you a pretty impressive representation of what that would look like when you're actually in the Suka, even though none of the training data was taken from these points inside. And the table looks pretty good, in my opinion. You can kind of see the boundaries of where those splats lie, and it was able to capture that pretty well. So yeah.
So capture the nearby building.
Yeah, I thought that was pretty impressive too. I think it almost captured that a bit better, just given how.
Too far away.
Yeah, if you run too far, you'll fall off the map. Yeah, maybe I'll end with that. But the building's pretty regular, and it had a lot of images of that in the back. I thought it captured that impressively well, given that wasn't even the subject matter of the photos. But yeah, here, I just keep running. So as you get farther and farther away, you can see that there was less data on what's going on over here, and it doesn't have quite as many splats representing it. Yeah, I mean, for how far? Oh, there you go. And there goes the Suka.
We can reset the position. All right. Questions? Go ahead.
How long did it take to like get this like raw like processing up?
It depends on all the parameters that you specify before you go to train it. So the first time I did it, I was using downscaled images, and I had the threshold set pretty low, so it would stop after it reached a certain number of splats representing it. And that it said it was going to take like an hour or two. It took like 6 hours. The final model I tried to train on my machine was I ran it for like 2 days. And near the end of the second day, it like froze everything and crashed my computer and had to like do all sorts of disk cleanup. It really messed something up. So I'm not sure, Ming, how long did it take to train on yours? 3?
Yeah, really GPU. The latest got a number. Really big one. Yeah, that takes just 2 hours.
Much better than mine. That was the one, same settings as took like 2 days on mine, never even finished. So that was pretty impressive.
Right, the file you actually exported from the training is a
PLY.
PLY file, which is the standard file bring into Unity or Unreal. So in Unreal, I set up it's called a third-person view of a robot that we display. I think this is extremely well, especially when you have like vegetations. I think there's a bamboo, right, on the wall. Yeah, with the standard photogrammetry, you won't be able to get bamboo because they're all very sharp groups.
Yeah, compare that to this.
I think that's like how much better it does the photogrammetry. So it's like the input is the same.
Right. Going forward, I'd love to mess around with the neural radiance fields, the nerves. The program PostShot that trained the Gaussian model has a setting to use the neural networks. In theory, that takes longer. It's more computationally intensive, and then the output, what it's doing is it's calculating. So it has like the algorithm that the neural network has trained, and every time you have a new view, so say I shift my perspective like this, it's going to have to recalculate all these things, running it through that algorithm every time. So it's a lot more computationally intensive than just having these Gaussians modeled in the 3D space and being able to run around those.
Experiment with nerve, that would help. Happy to help you to train.
For sure.
Yeah,
Thanks.
All right. Thank you. If you can switch back to laptop. Yes.
Keep the recording going.
Yeah.
Yeah.
Okay. That's it. Yeah, I'm thinking, yes, recording is still on. Just want to double check. Make sure we are not missing it. Yeah, I think it's good. Yeah. Actually, cute to that. Yeah.
I know I'm shorter.
Good. Don't mind to minimize this.
Okay, so I don't have to look at myself. Okay. So I was looking at how it can like work with the historic documentation process. Okay. So I was looking at this like historic single family house in Newport, Kentucky. It was with the class that I was doing with like historic documentation. And so we were able to work with like a client and using HAB standards. It had no floor plans, no elevations, no section drawings, so everything was done on site. And I wanted to see how like 3 different 3D scanning apps would be able to help gather information, and then also compare each program's effectiveness. A little bit about historic documentation. It's a process where you gather measurements, photographs, and research to do a cohesive and comprehensive drawing set. And these are done on site, and it has a certain standard. This is the house that I was working on. So it had like the front elevation and then the living room, which you'll see in a scan, and then the central staircase. I worked at different scales for these as well because certain scanners worked better in like large areas. So I wanted them to be free and accessible scanners. And so these are ones that you can get on your iPhone without having the fancy phones with the built-in scanners. So I use Scaniverse, Reality Scan, and Polycam. First with Scaniverse, and I think ultimately this one was my favorite. This one you kind of like have a video ongoing on the app. And so you can go as long as you want for like getting all the angles and all the rooms and all the process. And it has 3 process options: fast, area, and detailed. This one is the raw data of a 10-minute scan, but I went back and I was able to do like a 45-minute video scan, and it was by far a lot better. Obviously there are missing parts. Obviously, they're missing parts. You have like floors that went away and like walls that went away. And I think a lot of it is because of the state the house is in. A lot of things are damaged or like floors are like through. But ultimately, I felt like it gave a pretty good idea of the building if I wanted to use that to go work on my drawings. Reality Scan was more of like a middle ground scanner. It works really well for my living room space, but it didn't do well if I wanted to do multiple rooms in the house. So this one has about 1,000 polygon count, which isn't too high considering, because I saw some online that they were able to do so much more. But you also have to make sure that it's in a specific string of images, and if you break that string, it also hurts the scan. So this was about 220 images, and this is the model that it would give me on the app. And then Polycam, everybody seemed to like it, but it didn't work very well for me. It worked well on like small items, but it didn't work very well because it was constrained with how many pictures you were able to take for the scan. You were able to take 150. You could take more if you got the premium subscription, but as far as accessibility, it was really only used for a small scale. And so you can kind of see it definitely had some errors, but the like chunk of the stair is right. It gave an extra little stair at the end, but for the most part, for a house that's kind of like demolished, it was doing pretty good. And then I put them into Rhino to see how those would relate, and Scaniverse was very bubbly, very glossy. I felt like it gave kind of like a weird vibe into it. They weren't actually like photos. They were kind of rounded everywhere. But Reality Scan gave really good, sharp features. I wish I zoomed in. I don't know if I did. Yeah, the fireplace was really like detailed in the Rhino scan. So that I was really excited about. And then Polycam was pretty much the same as Scaniverse. It was kind of bubbly, but it did give a little bit more detail than Scaniverse. It was kind of like the middle ground between all 3. And then my conclusion with this is that even though they can be helpful with kind of getting the idea and getting the layout of the building, the accessible scanners on your phone aren't to the standards to be able to use that as a documentation tool for these buildings. If you were to get like Polycam and get like the premium, I could see that being very useful. But as far as the little dinky iPhone scanners, I don't think that they're up to those standards. And then a question that I also wanted to pose was that if the end product of these 3D scans took away any of the integrity of the buildings for the historic process. And that's it.
Yeah, I agree. I think there is always a tendency for this app to smooth the geometry. So you have a sharp corner against the ORB
Yeah.
mounted.
Yeah, like bubble gum.
Yes. Yeah, I'm glad you did comparison. That's great.
Yeah.
Cool. You said that you were using a phone that did have the built-in LiDAR.
Yeah.
I was wondering if like you knew anyone who had like a phone that had the LiDAR, so you could like maybe see like if, just like on like a smaller scale if like the LiDAR versus no LiDAR made a big difference to that.
That's a good question.
Because like I think like it can within the same app it can use it or not use it, right? So
Yes. Probably. There was one app, I think it was probably something. Like Imagery, maybe? And that one was using LiDAR, and I couldn't even get onto the app without having it. But that would be a good question to see how those would work if I was using a phone with that. Yeah. My phone's too old. I know that Alec was using it on his iPad with Rhino, but I don't know if he explored apps on his iPad or if he just did the Rhino at different scales. Yeah.
Thank you.
Thank you.
That's also like $5,000 laser scan.
Like get out of you.
You can just simply go back to.
Oh, there we go.
Yeah. Click. I'm using that. Yeah. Let's just see close. And you go back.
Oh, come on, go. Oh, your hand. How do I get rid of it? Oh, do I just click on? There we go. Oh.
Just click your screen. It should be gone. Oh.
No.
Okay, let's give me a second.
Okay.
Just close this.
another.
Right, there we go. Yeah, I'm not sure what happened. Just
Okay. So for me, I wanted to explore giving a future for forgotten sites through digital heritage. So my research question is, how can digital heritage technologies be utilized to document, preserve, and educate people of sites that have been raised in order to increase participation in digital heritage on a day-to-day basis? So some key research findings that I found was that there's recently been implementation of online exhibits and innovative services that have enhanced accessibility and have attracted new audiences to digital heritage, such as like a younger crowd. And another big thing that I wanted to focus on was like there was a lack of participation in it, so I wanted to increase that. So my main goal with this project was to create a 3D scan of a historical site or object that will increase community engagement in digital and cultural heritage. So I started off with like some scanning practice, and then like the last presentation, I thought that Polycam was really easy to use, especially for a beginner. I did both Polycam and reality scan, and I found that reality scan, maybe it's because I'm impatient, took a lot longer, or I just didn't take enough pictures. I don't know, my model didn't work, so I just kind of stuck with Polycam. And yeah, I think I got a pretty good scan of just something small. Next, I scaled up and went to an interior of the room. This is just my living room. I think I got a pretty good scan with everything that was in the room, representing it. And then, so for my actual project, I wanted to focus in on the Laurel Homes Historic District, which is right downtown. It's right next to the TQL Stadium. It used to be a 29-building public housing project. It was originally listed on the National Register of Historic Places in May 19th of 1987. It was originally built in 1938, and it had over 1,300 units that were both leased to white and, to a lesser degree, Black families, making it one of the first integrated housing projects in the United States. It was the second largest public works administration public housing project in the country, and then in the early 2000s, all but 3 of the buildings got raised, and then today it's just a condominium development, and then at the southern end, the Cincinnati Parks, they developed it into Ezra Charles Park, and you can see in this photograph all those buildings that used to be there. So originally, I wanted to scan one of the units in the public housing projects. Unfortunately, I wasn't able to get in there. There was no unit for me available, so I can actually scan. So I decided to just scan a part of the site of where the buildings used to stand. I found that doing a landscape scan, especially with Polycam, was fairly difficult. This is some photos of what's there. Now it's just roadways and just like open space where you can like walk your dog. So I scanned this like middle roundabout. It's an okay scan. It's okay. Like in the last presentation, Polycam is better with doing smaller objects. So I went down to the park, walked around, and I found this statue, and I decided to scan that. It's a statue of Ezra Charles. He is a heavyweight boxing champion from like the early 1900s, and he's originally from Cincinnati. And then I decided to publish this. I thought the scan was fairly well, so I decided to publish it to Sketchfab. And Sketchfab is like a place where you can like buy models, and designers can like upload like different models of different things, and you can do different things with it. There's like different layers. Yeah, all this fun stuff. Oh, maybe not. Okay. Well, it was working on my phone, on my computer, where there's all these like different mappings and like textures that you can get from it if you wanted to analyze it a bit more. So in conclusion, I'm hoping that these scans can be used to increase participation and engagement in the following ways. It can be used at development meetings where the community is open to the public. They can actually come in and actually have a say in what's being developed in their communities. Because I know in the past, in my experience, there's just been developments that just happen. And I'm like, our community really doesn't need that. So they're actually getting a say, and they can actually be hands-on with these scans. And it can also be used in primary schools to get students more involved, like in elective courses such as like real estate and like development, so they can actually get a say in their community as well as start using their spatial organization skills. So yeah.
Yeah, I'm glad you touched the dissemination, right, of the heritage. So once we have the 3D model, what is the way allow other people to have access?
Yeah.
Like Sketchfab and other maybe mobile phone would give you that kind of quick reach. Right? You in the future you may also consider push this into some kind of metaverse.
Yeah.
Right?
Yeah.
So then people can just
Walk around, actually see it.
around.
Yeah.
I think the outdoor natural, environment with trees, landscape. I would imagine, photogrammetry will always have issues.
Yeah.
It's not about the original recording device. It's then about how to handle this finding.
Yeah.
In the Gaussian experiment you did, what kind of camera windows? Just a regular?
It's a DSLR, so they're pretty big images. It's an iPhone.
Okay. So it's professional. Is a video record or just picture?
There's just pictures. Or repeat preview.
Okay. That makes sense.
So down to
Yeah.
But then
Yeah, and that's what I thought. It got like a fairly good like scan from it. So I don't even think I think I did like 120 or something like that. I didn't even get like all the way to 150, and I think it came with a pretty good scan. So
thank you.
Thank you.
So Mackenzie,
Mhm.
really stop doing this. It's the exact same PowerPoint template.
Really? We sit next to each other. What can we say? How do I get it? Do I just?
All right.
Do I?
So let's move on.
There we go.
Oh, all right. Who is the next person? I think if digital heritage is all presented, we can move on to digital twin. Right? Okay. So who is available from digital twins group? 2 of you? 3 of you? Okay. Whoever name is on the top, go first.
I thought you were. I think you're ahead of me alphabetically.
Which one's in the hall? Yeah. So the other one. Right on. Let's now contribute our details. There are critical responding on the lens. What is it? Lens.
I don't remember what I used.
And make it not have the.
No, that's fine.
Okay. All right, so I was doing digital twin and using the same PowerPoint template as Mackenzie, because of course. So I kind of cover 3 areas. What is a digital twin, digital twins in architecture, and then a case study. So what is a digital twin? It is a hyper detailed digital model of a building and the building systems that has a whole bunch of data associated with it that allows you to manage the building in a really unique way. So in order for it to be specifically a digital twin instead of just a BIM model, it needs to have the model of the object, an evolving set of data relating to the object, and a means of dynamically updating or adjusting the model in accordance with data. The focus of my project is more on the original model of the object and less on the data, but those are important aspects of it being a true digital twin. So in architecture, we have BIM models like Revit that are getting more and more popular. And so we have these BIM workflows, so why are we not already moving towards digital twins? And some of my theories for why we aren't moving that direction is lack of exposure, of not knowing that these tools exist. This class is the first time that I had heard of these tools. Misconceptions about how much coding knowledge you need in order to use them. Lack of infrastructure. While a lot of architects are using BIM tools, the models are often built for a different purpose. They're built for construction documents or for rendering, and they're not necessarily meant for the data tracking. And then intellectual property concerns, whether it's, so usually it's geared towards the operations and the building management and not the architect. And so if the architect owns the model, then where does that ownership go? Where's the support for that? So I wanted to look at what it would take for architects to transition from a BIM model to a digital twin, looking at what steps need to be done, how modeling can be optimized, and then how they can benefit the architect and the client. So for my case study, I was looking at 2 existing Revit models. I was looking at my core house, which was an academic project. It was about 1,400 square feet, but it had a focus on design and renderings. It was mostly interior, but because it was a studio that was focused a lot on building systems, I did model HVAC and plumbing. I modeled framing, and it was furnished for the renderings. The other project was a maintenance building that I did on co-op. It's a similar size. It's about 2,200 square feet. And the focus of that project and that BIM model was for the construction document set. So here are a few pictures of the core house and what kind of drawings the model was intended to produce. You can see they're a lot more design drawing focus and a lot less technical, but I do have the modeled HVAC and plumbing elements in there, as well as the modeled framing. This was the maintenance building. Obviously, it was used as the CD set. I did have these sort of color views, so there are materials and some sort of attention to the 3D elements. It's not entirely just 2D, but it is more of a focus on the construction documents. I was careful to consider some of the potential biases of these projects. The academic project was part of a studio focused on building systems, so it was a lot more technically detailed than typical academic work. And the professional project was done at a firm that was at a really weird point in its growth, and so they didn't have a ton of Revit guidelines, and so the model was pretty messy, and a lot of information was drafted in 2D rather than shown in 3D. So my process was bringing the files into Tandem with no cleanup whatsoever, and documenting sort of the first impression, some of the problems that it was having, and then cleaning up the Revit models, re-importing them, and sort of comparing and contrasting how it went for the 2 different options. So here's just an overview of the Tandem interface. It's pretty simple. Once you make your account, you can just create a new facility, enter the project information that you want, and
upload a BIM model. It takes just a straight Revit file, so very little effort if you're already working in Revit. And so this is what it looked like when I got the core house into Tandem. It was a fairly clean file and things were pretty good. You can see in this image some of the problems that I was having. For example, like this wall is kind of on some sort of phasing problem, I think. And some of the window trim was like having some weird level association. And some of the HVAC was showing up weirdly when I was working through it. The maintenance building was a little bit messier. You can already see like there's a lot of levels going on. There are no building systems modeled because they were in the consultant models. And you can see, you know, again, like this wall is disappearing for some reason, and these interior walls aren't showing up on this level. And there's some weird level associations, some weird invisible walls, a whole bunch of excess bloat geometry. And so then with the cleanup set, the core house was pretty simple. It was mostly just object property changes. There was very little like actual modeling work. The maintenance building was more involved. There was a lot of troubleshooting of display problems, of like things being set on weird ways, and then it required a lot of deleting of large portions of geometry because the file had been copy pasted so many times. So in my conclusion, I basically concluded that the core house worked a lot better because it was used for design drawings, and so more of it was physically modeled because it didn't need to be depicted with as much detail. When you need to show more precision, things tend to get drafted rather than modeled because you can be a little bit more precise with how exactly that goes together. And so the more you can model, the better. In the future, you could potentially, to bring out this digital twin, add metadata to these projects. That's not the focus of my project. I was focusing more on the workflow transition from Revit to Tandem, but I was comparing sort of these two different types of buildings and the different types of metadata that could be worked into them. So live temperature and humidity sensors, some work for specifications, remote lighting controls. The main building, you could have like door access logs to see who has access to different rooms. I also was thinking about equipment reservations. The building has like a dog wash area of it, so you could like reserve equipment if you lived in the apartment buildings there. And then in conclusion, when you build your model with good practice, it's really easy to get into Tandem. There's very little that you need to do, as long as you start with a good Revit model. So in order to optimize it, I think that this list sort of summarizes it of having strict standards for modeling, model components instead of drafting wherever possible, avoid using generic model families because you can't filter them as well. That's just general Revit good practice. I know we're all guilty of using generic models way too much, but they do sometimes cause problems with filters. If there are consultants on the project, coordinate with the rights to the models and which models you have access to in order to maybe upload all of them there. So you could have the architectural model and the structural model all in the same digital twin. And then be careful with your level association. That was the major problem that I was having, of things being associated to the wrong level. And these are my sources. Thank you.
Glad you focus on the workflow. Yeah, go ahead.
Do you use like generic models? Like when Tandem just like not work?
Well, it works. It's just it's harder to like filter them, like to hide or show different things. You would have to add extra like parameters. So you could add a parameter to like a generic model to tell you like what kind of object it is so that you can filter it better. Yeah, change it from a generic family to like an actually like classified. Yeah, I know what you're talking about, but I feel like in general we are really bad as architects about doing that. Like I feel like very frequently things just get modeled as generic models.
That's the key about DIM, right? It's about information.
Mm-hmm.
So the metadata,
Yeah.
the property data is super
Yeah, and like that was sort of like the main thing that I realized is that like it really depends on how strict and cleanly you're doing your modeling. My core house, I was working on it by myself, and so I was able to sort of keep things a little bit tighter. Whereas the maintenance building had passed through a bunch of hands, and so things kind of were already there, and things were done weirdly, and so it was sort of a lot of like retconning of stuff, and so by that nature, it just gets messier. And so I think realistically, most firms are kind of somewhere in the middle of that, where it's not quite as a mess as that one, but it's not quite as clean as the other one. And so it's really about finding a workflow that works for that firm in terms of their modeling process. Yeah, so Tandem isn't actually like linked live to your model. Like once you upload it to Tandem, it's completely detached from your Revit model. So I think you can actually connect it to a BIM 360 model, like if you have it in there. I don't know if it would then be live updates if you do it that way. I don't know, but because I just uploaded it like from my computer. So that could be something interesting to look into if that then becomes a problem with like relinquishing ownership of elements. I don't know.
Transitioning architecture type technology. Do you think that digital twins are something that are being built, or that maybe it has more specific use cases?
I think it's really dependent on the program. I think certain areas are really like more inclined to like benefit from it. So like, for example, like it was easier for me to come up with ways to use like the digital twin data tracking with the maintenance building because there's more like systems going on, there's more different things happening. Whereas if it's just like a single family residential project, like I don't know, you have your smart lights and like your temperature, like that's kind of it. And so it doesn't feel like it's as worth it for something like that. But I think if you have a lot of building systems happening and like, I think you guys were looking at different like kind of programs, like someone was doing a restaurant and someone was doing I think you were doing a hotel, right? Yeah. So like, yeah. So like if there's things to keep track of, like with the hotel and like a restaurant, like keeping inventory, keeping like booking rooms, like had mentioned like the possibility of like equipment reservations or something. Like I think that makes a little bit more sense. But when it's something small and like a single family house, like there's not really much point to it.
For sure. Yes, Adrian.
So you can imagine like there's a lot larger going to a lot of systems going on. Backend city on versus just the house. It's not really.
It's already kind of like, I feel like most single family residential don't even make it into Revit to begin with. A lot of it just stays in AutoCAD because it's so small and it doesn't even need to make it there. So yeah, the scale is just kind of different for everything. Yeah. Yeah. Yeah.
Great. Thank you. Yeah, we have other digital twin presentations. We can definitely continue the conversation.
Why?
Go ahead.
How do I make it stop presenting?
See, perfect. Good, you can.
There we go.
Yeah, and close. Good.
Oh,
So you are in the digital twin. Alright, let's see. We'll try to get both of you.
I'll speed it up. Okay, so I also did digital twin. I kind of focused on the route of enhancing hotel management through like inventory. and also kind of returning ROI on customer experience and just general knowledge about the building. So we've kind of already went over this a little bit, but what is a digital twin? Yeah, that works. It's a virtual replica of like a physical object or system, and you kind of use it to use sensors to kind of send feedback to your model to kind of run operations or various analysis to kind of help you with optimizing your building. So it kind of works with data collection through sensors, and then that data connection is sent in real time to a computer program, such as the digital twin, and it updates the model virtually and starts running analysis testing, and then sends that feedback loop and starts all over again. So it keeps optimizing and learning and making your building better. So I explored Tandem, which is the Autodesk version. It should be free to all students. And this is kind of a step-by-step on how to make it work. The first is just by starting with a BIM model. So aggregating data from any source such as SketchUp or Revit works. And you can't really model within Tandem, so it's better to put as much detail as possible within your actual Revit model. So for this specific case study, I took just the core block of a typical hotel, thus being like a back of house, a lobby area, and a typical suite. From there, you can kind of export your file just as a Revit file, and you can create a new file and import it into Tandem. So kind of like Ella was saying, you can't link it to it, but you upload your file location, and then as you save it, it'll automatically update. Step 3 is kind of setting filters. So just like in Revit or AutoCAD or anything where you can hide your elements, they have their own filter system, which is very easy to help search or clean up your model as needed. And then part 4, this was kind of diving into the inventory management portion of it. So I didn't really mess with the sensors too much, but I more or less messed with manually inputting data. So each element you can go in and edit the family to have custom text parameters. And then from there, those parameters will show up in Tandem when you click on the element, and you can edit the data within. So I can't really read that, but it could say like 5 towels are left or something on the shelf, right? So you can manually update that, or if you did include sensors, that would be where you would see it. And it kind of goes the same way with room parameters, and this is more or less helping client relations. By clicking on a room, you can see any data that the hotel wants to show you, such as like price, availability, square footage, anything like that. And it works the same way as creating custom parameters for a component. So moving on, there's not just one digital twin. Almost every software company has one. Unreal Engine is a really cool one. This is one that I would like to explore a little bit more. It's really based on graphics and larger scale operations. And I found a really cool case study by Mirza, who's kind of doing the same thing that I'm doing. If you look at the bottom right picture, with real estate and apartments, and you can see that like they included features such as like sunlight, which orientation it's facing, room size and price and availability, and a really clean, like user-friendly looking model. Moving on, NVIDIA has their own, and it's best for real-time collaboration and advanced graphics. So you can see it's kind of used in a lot of industries on larger scales to even smaller scales, just as like this little apartment here. And then Amazon has another one, and this is just for scalability and integration. Amazon was really big on using AI learning to kind of adapt and learn from your model. So over time, it'll automatically update and grow your model and run predictions for you instead of having to manually do them each time. Yeah, that's a quick version of it.
Questions? I also thinking this is good. I like you have a comprehensive discussion on the digital twins multiple platform on usage. I'm also thinking for hotel, Tandem allow you to save wheels. So for each room, we potentially allow the user view to go in and see exactly the views, right? So there's the ocean view, city view, that. So I think that is another perspective, not from the management perspective, it's more from the users.
That's what I was going to say, because you could link your tandem model, because it's all on the internet, so you could link it, and users could go into a cleaned up version of that model and click on the room and see what they want to see and zoom and move around. So.
Exactly. But also, you guys all know the power of the metadata Rabbit.
Mm-hmm.
We are able to put a placeholder there and later instead. Thank you. We'll have one more for today, right? For others, we have to wait for next presentation day after the Thanksgiving.
All right, so my digital twin project sort of talks about the process during the creation of the BIM model, and then also how it can be used after. I do think it's worth it to create, especially like in a sense of like a development. It's important to create a BIM model for even like a small single family house, just because I think it can then be used after the fact. So it kind of like makes sense to use one, especially when there's like 50 of a similar house in one development. So I'll take you through the example house I'll be using. It's just a simple 2-bedroom house with the public spaces on the bottom floor and then bedrooms on the top. So next up is the series of sensors. And so these sensors are, the idea that it'll promote collaboration between the trades during the initial design process. So as an architect, we'll go through and design the exterior in the BIM model, whatever it is. Then the plumbers will come in and do their thing, and HVAC. So it's all in sort of in the one model, so it'll streamline that process. And in doing that, we can put in these sort of sensors in the model that'll collect data in real time. So I just have listed a few here. There's temperature, humidity, air quality, airflow, and even seismic activity. They have different purposes, to detect fires, any moisture infiltration, if there's a leak in the roof, say, carbon monoxide, leaks in the HVAC system, or even structural movement. And they're kind of placed depending on what the purpose of the sensor is. So like you would put like a seismic activity one in the foundation or maybe even the walls to see how it's reacting to wind or even settling movement in the ground. And airflow and air quality will be in the HVAC vents. So I'll move you through some example data. This data is fabricated just for the purposes of this example. So here are just some normal systems. The idea is that these sensors will collect data in real time and will sort of automatically detect like a normal sort of flow to it. And so it'll know when things go wrong. So like, for example, next up is anomalies. So like say there is an energy consumption, all of a sudden it peaks. And it'll detect why, or at least it will detect the peak. And so like in this case, this one is an alert that some appliances might be left on or even a faulty HVAC system. So it might be time to look at the furnace filter or just schedule some maintenance because it's not working as optimal thing. So, so even like temperature is a pretty easy one, especially in the kitchen where, there's lots of things that could catch on fire. So this one is a 200-degree anomaly. So, and in this graph, it'll show that it was promptly extinguished because the applicant was alerted that there was a fire. And so it can be put out, which can very much decrease structure fires and everything like that. And then this next up is sort of just graphics of how users can be alerted. And the idea is that all these sensors are hardwired into the house. And so there's an interface, sort of like how an electrical box with like a switcher board is. And then from there, your phone has an app that can connect to that interface. And then that'll give you all the real-time data on your phone, which will then give you push notifications if something needs your assistance. And I think that's it. So the idea behind this is that it'll enhance building safety and also promote collaboration between all the trades.
by monitoring the conditions real time and also having a streamlined process for having all the building systems in one model. So yeah, and the temperature tracking and all that, all these examples here are just a few things that can be deployed in a BIM model. That's it.
Questions? I have a question. I think there's already some apps in the market. I have a smart sensor at home, push the data to a mobile phone. So if there's someone break the window, you get alert. Right?
Yeah.
Temperature change.
See, my problem with those is that there's a bunch of individual ones. And so it's like, yeah, there's, home defense systems and things that alert you, but then there's, Bluetooth. So there's like 50 sort of like Bluetooth, like wireless things that you can connect to your phone. I feel like that's just, that's a lot for like any device to handle. I feel like hardwiring it into one sort of interface that will then produce one signal is a lot more streamlined than having 50 wireless devices connected to your phone.
Right. And I think I use iPhone. There's an app called Home. You can link multiple devices there. You can also monitor if you have a robot cleaning the floor, track the position of it. So my question for you is, what is the benefit to have a three-dimension house model as a digital twin?
Yeah, so something I should have shown was a graphic representation of how it'll alert you, because it won't just say like something is happening. It'll also like show you where. So I guess there would be like an alert, like say, like it'll show you graphically in the model where it's at, instead of you just having to guess. Like say, there's an HVAC leak. It'll tell you where in the ducting is the problem because the HVAC consultant had already modeled it. So it's actually in the model. So it can be easily detected. And so you know exactly where it is. You don't have to go through and check the entire system. So that's the point of having the model. I should have had a graphic for that.
Yeah. So that means the density of the sensor should be able to allow you to pin down the possible locations. So that's not just like a simple smoke detector. Will be involved.
Yeah, like I'm thinking like in each supply vent, maybe, or even like in a return. Like if the return vent is, it has a low air flow, then there's probably needs to be clean because, things occluding it. Or even like a supply. If the supply is starting to go down, like in how much how much air it supplies, then there's probably a leak somewhere in that sort of branch of the system. So although it's not like this one section needs to be replaced, it's more of something between here and here is wrong.
The thing sensors say on like specific the plumbing or HVAC, I would just put like say moisture sensors all over the house to see if there's like mold accumulating in the walls.
I haven't seen that, but that's sort of another idea. Like I'm thinking, just like in older houses, like that are made of brick, where water is a big problem. I was thinking more like in my case, like especially in my home right now, there's a leak in the roof, so I feel like a moisture sensor in the attic would be a big help, or even somewhere like in the basement where there might be water coming in through the foundation walls. So I think things like that could really help people understand, like, especially if there's moisture detected in the basement, you can also assume there's probably in a basement vent settling in that area from the ground eroding away. So I think there's a lot of preventive action you can take that can also just stem from one sensor.
In my house, I don't need a sensor. There's always moisture in the basement.
Yeah, there you go. You can use your eyes sometimes. You can just, your eyes are your sensors, so.
Yeah, if you this is a good starting point. If you like to continue, let me know. I'll be happy to lend you my sensors. Back home and try to somehow link it through a IT network to the tandem. In the tandem model, you can actually see that the data, abnormal detect. You can also try Arduino, other DIY, right, to link the data to as possible. Thank you. Cool.
It's computer-based designs that kind of provides instructions and feedback to learners, students, and then it uses AI to track their progress to help them achieve specific educational goals. And then my survey results, kind of the overview of it. I had 44 students, first to third year. Major findings of that were they all had a strong interest in AR's educational potential. They were eager about kind of the hands-on learning aspect. And then obviously there's mixed opinions about device access and high costs. And then how AR enhances spatial understanding. 50% agreed that it'll help them visualize spatial relationships better. 40% saying AR promotes collaboration and creative thinking. Some challenges mentioned earlier, lack of access to devices, and then high implementation costs. And then I did research on other university in Virginia, Shenandoah, from Dr. Obed, if hopefully I'm saying that correctly. I tried to set up an interview with him, never heard back, but I found some articles online about some interviews he's had and like how and what he's talking about AR implementing that into education. And he noticed that integrating it was really good for spatial learning and design visualization, but obviously there's limitations in software compatibility and then ensuring faculty buy-in for the newer technologies. And then impact on skill development. This survey found that AR enhances the visualization of complex designs and students feel more engaged through the hands-on AR activities. Dr. Obed's experience AR has helped students understand forms and structures in a more realistic way, and it supports creative exploration of spaces beyond traditional methods like hand sketches or model making. And then ITS potential in architectural education. Survey results, 50% believe ITS can provide personalized learning paths, and they view it as a tool to enhance engagement and problem solving. Dr. Obed's perspective was ITS can complement AR by offering personalized feedback per student that allows like adaptive learning paths, and then it can just support interactive design processes as well. Learning outcomes with AR integration would be 40% of students saying they report that they would have improved engagement with more hands-on AR projects, as well as understanding spatial design concepts. And then Dr. Obed's kind of point of view were improvements in student creativity and spatial problem solving, and the technology allows for deeper engagement in courses involving 3D modeling. And then kind of cross-examining this with other fields, such as the medical field, that there's some universities and some hospitals that use AR for medical training to simulate complicated procedures, but it could very well inform architectural education by kind of providing students like a walkthrough of their designs. And then engineering, ITS for real-time problem solving, and it can be adapted to architectural design critiques. Dr. Obed's kind of take on that was cross-examinations of different fields show that AR and ITS should be adaptable to allow students to explore solutions in real time. And then kind of the scalability and resource management of all. Obviously, the lack of devices and the high costs of it. And then Dr. Obed's kind of advice on implementing AR would be just kind of start smaller and smaller scale courses, and then leveraging cloud-based platforms to keep costs low. And then kind of a future outlook on it. 50% of the survey believe that AR will impact architecture in the future, as well as ITS has the potential to redefine how students interact with complex designs. Dr. Obed's kind of vision was over the next decade, AR and ITS will reshape architectural practice by allowing more immersive learning environments. Conclusion of it, obviously there's a high potential for AR. Students see it as a valuable tool for visualizing and engaging with architectural concepts. ITS integration, meaningful potential to kind of personalize learning paths per student. And then obviously there's going to be a heavy focus on accessing these devices and the training that comes with it, as well as the high costs. That's it.
So I have a question
Yeah.
for the 44 students survey, right? That's from Dr. Obed's.
No, that's one I conducted myself. First, it was predominantly architecture, but as well as some like graphic design. Yeah, the first to third year mainly. So
I'm very curious. How do you conduct the survey? Set up table?
No, not even that. I kind of just walked into classes and just asked if I can just provide a survey. So, and then not everybody took it, obviously. That's why I only had 44 people, but I feel like it's
still a lot.
yeah, it's a good enough range. Yeah.
Yeah, as a part of the final report, it include a little description about
Like questions I asked or whatever. Okay. Okay.
so if you just attach the as appendix of your survey questions.
Mm-hmm. Okay.
Nice. So I got a
Yeah, a feel for okay.
question. And also, I think also this could also be PowerPoint to add another 1 or 2 paragraph, report about hardware and software.
Okay.
Like what
Yeah.
are what devices are you talking about?
Yeah.
About iPhone, mobile phone, or HoloLens, or the AR glasses, right? So talk about that. For software, maybe you can use what are the top available softwares.
Okay.
For example, one would be Adobe Area, which is very easy to use for mobile phone.
Yeah, I was looking into also like possible funding, like finding obviously big companies to like fund possibly a class or whatever it may be. But obviously, I as a student don't have that much pull with companies, so.
Yeah, but just I think funding is relevant compared to hardware and software.
Yeah. Okay.
So adding that as a part of the report, because I think in the AR application, I saw people use HoloLens, right?
Yeah.
They will teach people how to lay bricks. I'm not really technical, it's called hologram.
Okay.
Right, but the argument is why you want to use this $3,000 device in the construction site, teach people how to lay bricks.
Yeah.
Probably that's not the best user scenario.
Yeah.
So something about the applications, hardware, software.
Okay. Yeah. All right.
Thank you.
Yep.
Cool. All right. Then let's move on. I think this is the only VR, AR, right? Oh, you are in AR. Yes. Go ahead. I will check. I just want to make sure I'm recording.
I think it is. It says stop. Well, that says stop sharing.
Let me make sure. I think I did hit the recording button. Did I? Go to, where's the, I have to go the other way. Or recording. Yeah, this is recording.
Yes. Okay. Okay. I have videos in mind, so I think I'm gonna do the PowerPoint version because I'm worried. Or unless they play in PDF version, but I don't think
I don't think so. You can open in PowerPoint.
Okay. Yeah, and then do slideshow. Yeah.
This works. Can you try if you can play video now?
Oh, you definitely can on PowerPoint.
All right.
I was able to last night. You can't.
Okay.
Wait, can I sign into my slides?
The file is fine. You just need to open it from the PowerPoint.
Oh. Okay.
Not the online version.
Okay.
So here, if you close it, right, which one is? This one.
Yep.
Yeah. So you're gonna download first. It's a download.
Two down.
Yeah. Then you can open directly in.
Okay.
In your software.
Oh, okay. Perfect.
This is YouTube. The video is on YouTube.
Wait, you still can't.
Go to enable editing. Oh, this is linked to a YouTube.
No, am I able to just sign into my Google Slides really quickly? Because I know it plays on there.
Sure. Go
ahead.
Can go to here.
Okay. Yeah. Uh-oh.
Really gonna verify. Yeah. Yes, it's me.
So
Sure. Okay.
choose not now.
Not now?
First.
Cancel?
Yeah, and then choose not now. You don't have to set up.
Oh, okay. Okay. Do I have to do this right now? I mean,
think so. Try cancel.
just, okay, I'm signed in.
Good.
I think. Continue as Elena. Not now. Okay. There we go. No, I need slides. Okay, here we go. Yep, okay. No? Okay, are you ready? Okay, so I studied augmented reality used in residential or being used in residential architecture. So my project goal was to one, study the history and progress of AR, find, learn, and explore an existing AR program. And then 3, create a client story to demonstrate my study using my own personal space. So why AR in residential architecture? In general, AR seamlessly blends digital elements with the physical world, elevating our interactions with our surroundings. And through everything that I studied and read, etc., I've found that there's many benefits to using, there's benefits to using technology and design in general, but specifically in using AR in a setting where you're working with a client and you're, designing something for them personally, I have found that it allows you to make changes in real time, saving time and money during specifically a proposal phase of a project. So for example, if, you and the client are in the mixed reality interface, and the client changes her mind on paint color, for example, the architect can easily change the color of a layer in Rhino, which updates the software in real time. So that's just one example of how using technology in, a normal design process can save time and money. It also enhances communication between the client and the architect, leading to less error. So rather than having unclear discussions about, discrepancies in what, the client is saying versus what the architect is saying, both parties can visibly see and move stuff to different locations in the software, and because they're both seeing the same things at the same time, it's much faster, and it kind of, like I said, leads to less error. Overall, AR creates an immersive experience for clients and architects in the home renovation industry that benefits and optimizes the experience for all parties involved. So, like I said, while it can, make all the logistical stuff of the design process faster, you can also maximize for a client what they are getting out of the experience, since you're able to create proposals faster and they're able to see those proposals faster. You get a lot more out of what you normally would in a design process. So next is software. Who is doing what? So I looked at a couple different AR, softwares and programs, but once I found Hologram, I kind of ran forward with this one. So they were founded in 2017, which really isn't that long ago. Right now they're used for Rhino and Grasshopper. You can see the list here of
how the mobile devices that they're currently available on. I personally used the App Store and downloaded Hologram on my iPad originally. And then after, that was during like E1, maybe beginning of E2. And after testing of using Hologram through my iPad, I found out it was much better used on my iPhone. So either iPad or iPhone, it both works. So examples of benefits and efficiency. So this was one of the examples done by Hologram themselves. This is just an experiment done where bricklayers were able to use the program to help build a complex structure. So the left picture is the video of like what we would see outside of the interface, and then the inside picture is what the guy over here using the headset sees. So I think it's really cool because once, you know, he sees the line work of the bricks, and those are like locked down and they don't move. So as he can see his arm, it's really cool. He can see his own arm like inside of the interface. It like perfects your craft pretty much. Don't know how he can go wrong with that. Just see.
On this complex fabrication project, so we went down to see what they've been up to.
So this is just the example video.
There is a single brick that lines up to anything. Every brick is different. This could take like 2 weeks for one guy, and a lot of that would have to be made up. You know what I mean? You're not going to get exactly like this one.
You guys provided a design model?
So here you can see like where the person can like pinch and change things inside of the system.
Aside from using Hologram as an instruction set, Colin was also able to use it to train his apprentice.
So that's all the brief.
So there you can see what they're looking at. Okay, we'll move on. But yeah, that was the gist of like the example work that they're doing. Okay, so skill demonstration. So I created like a little client, little story to kind of demonstrate how using AR in residential architecture, like what that would kind of look like in a real life setting. Okay. So this is my friend. She says, "Hi, I'm Rachel. I'd like to add a fireplace in my living room. I'm not sure what I want it to look like though." And then that's me. So, "Hi, Rachel. I'm Elena, an architect. Let's test out some designs using Hologram." First, she'll send over an existing photo of an existing wall. And then next, I'll need to draw Rachel's existing floor plan in Rhino at 1:1 scale. I feel like we usually, when all of us use Rhino, it is at 1:1 scale, but it is pretty important to make sure that it's as accurate as possible, because once you import that Rhino file into Hologram, it needs to be accurate for everything to line up. And then next, I just modeled her existing space. So I honestly didn't even end up needing to model all of, like the 3D work that I did in Rhino, but it was nice to learn through the process, and it did help in the beginning. Uh-oh. How do I go next? Where's the right button? Oh, okay. Okay, so now I created 2 different proposals for Rachel. One would be painted and the other would be wood. I'll make sure to place them on separate layers in Rhino. So this is pretty important for Hologram to really work. And then now it's time for Rachel to download Hologram on her phone and connect it to Rhino. So this video clip shows what it looks like to open the Hologram app on your phone. And so now what the video is seeing is what you're seeing through the phone. So, and you can see the purple button there. It says connect, and then it comes up with a big QR code, and you can just hit that and it connects within seconds, honestly. In the next video, we'll watch as Rachel aligns and locks the modeled existing wall to her real life wall, explores both option 1 and 2 by turning layers on and off, and then walks around to view the options with its surrounding context. Okay, so as you can see, a little gumball tool appears, and this was honestly the hardest part, is just trying to align everything, but that's why it's kind of important to have at least one kind of accurate wall or something of the existing sort to make sure that you can get that in place. And then once that is in place, you're good to go. It's honestly like an anchor point. It's like once you get the anchor point down, you're good to go. So that was the closest that I was going to get because I tried it thousands of times. Okay, so now you can see the existing wall. And then there's that little tool that pulls up all of your layers that you have in Rhino. And there you are able to turn on option 1. So here, Rachel's looking at option 1 and her existing space, walking around. So that's why I was stressing the importance of the anchor point, because it's once you have that set, then you're able to walk around and it doesn't move with you. And I also like to point out too that the Rhino and the hologram settings like go both ways. So anything that I can change in the setting will turn off in Rhino, vice versa. If I go to my computer while I'm in the interface and turn a layer off or change a color or something like that, it will automatically update in whatever I'm seeing in the interface. So now Rachel's switching to option 2, looking at the different options. So this is really cool. Obviously, it's not perfect. I think that honestly, I mean, my craft would obviously need to get better. You need a lot of practice with this stuff, but I don't doubt that even holograms themselves will continue to update and advance their program as well in the next following years. So yeah, so I just thought it was really cool. You're able to switch through and see stuff, and I think it's different than VR because you're able to, I mean, really for the first time when AR was created, you're able to see your existing space with something that you're created, and it's not one or the other. So yeah, that's it. This is just a quote from that hologram video that I liked. Cameron said, the really exciting thing about this project is that now Colin and his team can approach architects and enable them to design more complex things, knowing that he has the capability to build them. And I think that was just kind of the overall what I learned from this study is by using, I feel like there's a stereotype with, builders and architects and stuff. And it's like, okay, you can design something crazy, but that, can't always be built. And for the builder to say, okay, well, now I'm more comfortable. You can throw me whatever crazy design you pull up, knowing that I'm able to build it. That's really cool. So it really just, honestly, just takes design to the next level, just enhances it, benefits it. Okay. I think that's, yeah, escape. Okay.
I really like your project. I think this is better one than the break. I think be able to real-timely stream, right, the 3D content in the context is super important in the design field.
Right.
And I also want to highlight, since you have the connection to Rhino, Grasshopper, right? So if you imagine the parametric design pipeline Grasshopper, to like any of the sliders or change variables, you can see the update in real time, right? In Rhino, and that will update in real time HoloLens. In a hologram.
Right.
So the iPhone version will update simultaneously as the Grasshopper change.
Yeah.
So it's very, very powerful combo together. Good job.
Yeah. Thank you very much. Okay. I'm gonna sign out.
Yeah. So is there any other people in AR, augmented reality? If not, we're gonna move on to the metaverse. Okay. So I think we have 3, right? So let's follow the order. Whoever want to go first, the metaverse. So whoever go first. You go. Yeah. I think you are in, right? And you are in the metaverse too, the 2 of you. Yeah, so you'll be the second, you'll be the third. And you'll be the fourth. Okay. So have 4 metaverse, right? That sounds right.
Okay. So I decided to use the metaverse for architectural speculation, specifically using Roblox, because it's a free-to-play and accessible platform that has its own studio and like 3D modeling software. And so first I looked at some like examples of showcases that are already in Roblox. So these are more meant to show the ability to render light, sound, environment, and the modeling skills of the creator, and players are able to explore in a more casual, relaxed setting. So the platform allows for a multiplayer metaverse experience, but people are also able to explore architecture in extreme detail. And so I decided to look at two projects. So the Mies van der Rohe Brick Country House and Aldo Rossi's Plan of a Foundry. These are both speculative projects that have not yet been built. They are more like art pieces, and so I went into Rhino and I 3D modeled them to the best of my ability, since there's limited information about the actual like elevations and sections of these projects. And so basically took these into Rhino and modeled them and exported them as FBX files for import into Roblox Studio. So I decided not to use Roblox Studio's 3D modeling software. It's a little bit rudimentary, and I'm more comfortable with Rhino anyways. But being able to export into it was really simple anyways. And so being able to promote architectural education in an accessible community-based environment, making sure that everybody can come together and experience these projects together. And this is just a quote from Patrick Shoemaker, who is a principal of Zaha Hadid Architects. They have a metaverse based on the micronation of Liberland. And so he said, one of the main draws of metaverse is that it is, like a city, a shared platform and caters to an evolving, diverse, and self-organizing community of those deeply interested and invested in the metaverse. So these are just larger images. Another thing, I wanted to look at the color palettes of these two architects. So this is one of Aldo Rossi's paintings, and then Mies van der Rohe, taking these color palettes and using them to inform the design in the game. So this is just a screenshot of once Aldo Rossi's Foundry was imported into Roblox and colored and the textures were applied. And so I still have to import the Brick Country House in so that players can experience both simultaneously. And so this is kind of what it looks like with players able to socialize in real time in architectural experiences. And so next steps, definitely like adding more collaboration opportunities for players to engage with architecture. So being able to place their own blocks and moving blocks. And then this is just a short video showing. And there's also sound in the game itself to help with the ambiance. And Roblox also allows a moderated voice chat feature, so players are able to discuss things in the game as well. And it's auto-moderated, so if there's any form of like cursing or inappropriate discussions, it gets filtered out. So yeah, that's all.
Yeah, I didn't do that earlier. This will all follow. Two questions. So number one, it is available online, you can play.
Yeah.
So maybe in the final by the link.
Yeah.
So you can download that and play. Second is the view. Are you able to switch from third person view to first person?
Yeah, so I didn't show first person in the video, but you can zoom in and go all the way in. You can also zoom out really far, which is nice, so you're able to get more of like a floor plan view of the two together.
Third question is, who are those avatars?
They were just friends of mine that I asked to join so I could make the video. Yeah, but anyone would be able to join. Yeah.
Question Thank you.
Yeah, thank you.
Okay, so let's keep going. Do you want to be the next one? I think we'll try to complete all the methods today. Do you have another class right after?
Sure.
And then it was presenter mode? No.
No, just do it in the facility department.
No, I forgot.
Mhm.
Make phone.
Grab it
Right here.
Can we start? Okay. All right, title of our project is Back to the Past. It's where we combine digital heritage with aspects of the metaverse to be able to experience architecture, art, different things of that nature today that are no longer physically present in the world to experience. So in order to do this, we decided to like do a case study in order to kind of take our research a step further. We looked at some interesting old classic architecture, and then we also found some significant architecture in Cincinnati, and then finalized on Old Main Library in Cincinnati, which no longer exists. And that's where we went searching for information about Old Main Library. Went to the Terminal Museum, contacted people there to find this information, plans and sections and photos, which is what you're seeing here. And they're all very old and they're slightly difficult to read, which we'll get into later, and how that was interpreted into software. These are just some images from the inside. So I'll go ahead and talk about stuff on.
Yeah, so to start, it starts with more digital heritage of collecting all the original documents. So you would want any architectural drawings you can find, plans, sections, elevations, and then any reference photos of inside and outside. And then use those to generate a 3D model that would then be implemented into the metaverse. So right now, the way that we did it is to trace all of the documents and build the model using a BIM software like Rhino or Revit or anything, or SketchUp. Another option that we tested out was uploading the drawings and images into Triple 3D to generate a model. Both of these had some issues, which we'll go into, and then there's a proposed method using software that's still in development phases. So this is what we did, just tracing in Rhino. So just kind of used the section to line the plans up according height-wise, and then traced all of the plans, and then off of the plans built a model, and then hit it one more time.
And this is when we imported.
You don't have permission to play the file. Why? I changed access. We just have to log in Google.
Separately, so just
Yeah,
separately.
Where's log out? My
Click the down button, the down arrow next to his.
Oh.
And then
no. My keyboard is a lot wider. I'm struggling.
Goes not now. Just cancel this. This is not now.
oh, look at your sign in.
Good.
Okay, so now we should
No, go back and go open your drive. Just go open the presentation in your drive.
understand.
So this is what happened when we tried using the Triple 3D. This was just using the free version. So with the free version, you can only upload one.
Photo at a time.
Yeah, you can only do one photo or document at a time instead of putting them all together. So like when we uploaded a section, it came up with this weird thing.
It's starting to understand the head, like the poche, as something that's supposed to be extruded, but it sort of reads like a tile or something.
Yeah, like it could read the what was pocheted, so the cut lines were supposed to be extruded out, and you can tell that it did try to do some like column capitals a little bit. It just hit it twice.
Yeah, and then we tried it. Yeah, go ahead.
Yeah,
Sorry.
we tried putting in a plan, and it kind of did the same thing as section. It read the poche a little better, but didn't extrude as much. And then on the right-hand side is when we tried to upload an interior photo of the stacks area, and I don't really know what it came up with, but it came up with that thing.
Sort of pulled what was ever in the front, and then from what happened with the image, that side image, we kind of were speculating maybe we could Photoshop images of the inside and sort of like scan elements at a time and then take those elements, put them together to be the building so that like the software could better understand what it was looking at to generate a model, if that makes sense. Like take away the background, just have the columns shown, build that, then just do the floors and then kind of piece it together.
It also could potentially, there might be some potential, like if you use the paid version to be able to put all of the documents in at once, it might come up with a better model, but the drawings might still have too much, or the pictures might have too much in them for it to be able to extract well. So a proposed method, there are two different softwares that are currently being developed. One of them is called Rent 3D, and the other one is Plan to Scene. And these do exactly what we would prefer, and that is it takes architectural drawings specifically and will create a 3D model that you can technically walk through. So Plan to Scene, which is the bottom one, that really does that the best with the drawings, and then Rent 3D is helpful in the fact that you can also include interior photos, and it will map the photo onto like the wall, so you can still see all of the detail that you would from a photo. But both of those are still in like research and development phases. So
yeah. And then if we go back to sort of our initial method of tracing documents that we find and using images that we find, and build a 3D model from it, this is an example of using hyperspace to put the model in to then explore. It's a really large model with like a lot of faces. So hyperspace was very like slow and didn't like how many faces was going on. And then scaling it up to be the correct size was also like very difficult because again, I think of the size of the
of the file. In addition to, it didn't understand any materials, so even though I changed multiple things, it still read as transparent, which was less ideal for exploring a different space. I think there are different ways to do this that we could explore further in terms of even just putting in smaller bits of the model into hyperspace rather than the whole thing, and exploring piece by piece, maybe in separate files.
Questions? Well, I'm glad to see you cross AI, digital heritage, and the metaverse. I do think those three together. Something you reach the limits of software. I think Triple 3D not able to understanding the architectural drawings.
Yeah.
So not surprised. I think the hyperspace you probably have to simplify the building.
Yeah.
Down into components.
Yeah.
Inside. I think this is an interesting experiment to go through this process. Now, I think the manual modeling in Rabbit, right? This program tools.
Well, actually, it was Rhino and SketchUp.
Rhino?
Yeah.
Just make sure when using material, you use a standard customized material.
Okay.
Don't use glass. Don't use some special shaders. I think the default customized shaders from each.
Okay. Customized materials.
All right. Thank you.
Thank you.
Great. So let's move on. Who want to go first?
Oh, it was already open. Sorry.
Take over.
Still in the file.
Go close. Oh, don't close the team. That's all.
Yeah, close the team.
That's all. I will just sit behind it. I want you to close this guy. Well, actually, you're good. I sound you close the other team. Okay, good. Just want to double check we are still in the recording. Yes, we are.
So I chose metaverse for architecture for my project. So my objective was to explore how a metaverse can serve as a platform for effective design communication between multiple disciplines. So why metaverse architecture? I think metaverse provides very special understanding between multiple disciplines rather than doing a traditional meetings. And I think it enables real-time discussions and feedbacks from team members, regardless of their physical location. So for my methodology, I imported my SketchUp model to Rhino and imported it to a hyperspace after exporting it on OBJ file and GLT file. I faced a lot of problems like importing my file to hyperspace. So the first problem was hyperspace couldn't take models higher than 20 MB. So I had to import my SketchUp model to Rhino and reduce the file size. So I had to, by removing a lot of high quality 3D elements and original high quality materials were not read by hyperspace, so the whole model was appearing black, and it required me to change like incompatible materials with simple textures, and it involved going back and forth checking if the material is read by hyperspace or not. So it consumed a lot of time for me to go back and forth with changing the material. And What I would suggest for future hyperspace metaverse users would be prepared to modify and simplify the model without compromising the design integrity. If you are someone who wants to showcase your design to your clients or your structural or landscape architect or structural engineer, if you want to show as your the material as you have designed, hyperspace couldn't be the best option. You might have to explore other metaverse softwares. And I would like to suggest to test the model in hyperspace before inviting collaborators, seeing every nooks and corners of your model if it's readable by hyperspace. So if you want to join my space, like from your mobile, this is my QR code, and I also have my link that I can post on Teams right now.
Let's go.
And could I go back to the files?
Oh, you want to
Yep.
copy a link?
Oh, yeah. And I also have a video.
You have a video?
Yep.
Okay. Let me go back to our PowerPoint.
Oh, yeah.
I think I'm in so the mobile phone.
Mm-hmm.
And now really it's the
It takes some time to load.
for the Teams. Yeah, this is good place. Yeah, start a new post.
I just copy it here.
Having a message. Oh, yeah. So if anyone want to join for
Mm-hmm.
in the Teams post, you pass the link. Can you open the link now?
Yep.
Want to see space?
I have a video recording of it.
Oh, you have.
Yeah. File. So this is my model, and I have invited a structural engineer to see my model. It started with a handshake. So this is me walking my structural engineer through my project. I'm walking him through my exterior part first, and then taking him to the interiors. So walking through it was kind of a problem. Like we couldn't do it smoothly, but I think it was workable. A lot of my materials were still unreadable by hyperspace. I mean, some glasses. Like I was trying to change like the material of glass to like everything possible, but it didn't read the material.
That picture seems wow.
Mm-hmm.
So we'll have set up the surface as walkable.
Yep.
So that works.
So that was also one of the problem. Like I wanted to walk like in the elevations higher and up lower space. So I had to figure out like while importing, you need to check something. And
right now they're just teleporting.
Yep. I think this way you can provide a better platform for your structural engineer or your landscape architect to focus on rather than doing just a traditional meetings in computer or paper. It ends with a handshake and a high five. So,
any questions? Well, I think this is a good demo. As you know,
What I did is like a virtual immersion studio where my initial idea was like when I was like discussing with the clients with the plans, floor plans, and the 3D views, the most of them find it hard to relate the plan, 2D plan, and the 3D view of it. So I thought creating an immersive space where they can understand both the plan and the view, where how would they interact with each other and how it is related, so that it will be easy for the clients to understand. So that was the main objective for the work. And for that, I just chose Metaverse, and I went through hyperspace. So when the link has been shared to the client, all they need to do is like create an avatar and just join the link. And I did some like a meeting space where first initially we just talk them about the plan, the concepts, the views, and all the stuff in the meeting space. Just give a brief to them on what we are going to discuss. And after having a discussion with the clients, we will move them to the meeting space where initially the plans and the views is being displayed. And I have like added there is like laser points and all those stuff in the hyperspace where you can like point them and specifically show that this space is being this and this is being designed, so that they have like exactly they can note what you're like discussing on. And apart from it, I have like so this is the floor plan which is being displayed, and for example, I want to like explain them about this space, and I have like marked that space and have like a viewpoint over here where if they walk into the sphere, they can have a view of it in like a 3D space. And all these like are the hotspots where if you like click on it, it will just automatically walk you there. And I have like already presetly like designed it in a way that it has the person who is standing there like focus on the space which we want, so they can make sure that they are like having the view of the correct space which we are like explaining them. So if I click on it, it'll automatically walk there and have the view for it set designed already. And this is the sphere. Like if you're like explaining them here in the plan, and the place which you're explaining is like already like there's an input from our side before the meeting, so we can like select which view we want there to be in. So I just came up with the sphere. This was like done in Rhino, and the render of it is being imported here, and this is one of my studio works. So this is the plan of it, and if you like walk into the bubble, you can see the view like this, the whole view. And even if you see it in the like the Oculus or the Meta, whatever, then it'll be like in a more immersive way. Like you can see it in a 3D space, and it'll give you more depth and how the view is set up. And apart from that, I have like designed some lounge space and all the stuff going on, and this, and some space to relax. And yeah, so I'll just show a small demo. I think I have time. Yeah.
renderings.
Yeah, input renderings and 2D plans into, yeah, yes. And this is how like you have to like create your avatar, like you can change everything and just go in.
I think we have a lot of issues of customize this really.
Yeah, but I think I found like a small way to like crack to it.
By single template, existing template.
Yeah, I actually like designed my own space, but it was pretty hard to do that. So I edited the existing template.
And customize.
Yes.
Yeah.
Yeah, everything. And this is the hotspot we just like talking about. If you click on it, it'll just move there directly. And yeah, so if I click on the hotspot, it'll walk there, and I like design it in a way that it just focuses on the plan where I want to see, so that the client can go there and have a view, and we can like turn on the laser pointer feature, so you can like point on specific things and ask questions and doubts about to the architect. And then after done, you can like go into this bubble. So here I have like explained them about this viewpoint over here. So to have that, I made a sphere here where if you like walk in, you will get into this 3D space where you can have a view into this. It will be like good if you see in the VR, but since it's a 2D screen, yeah. If you do the first person view, you will have like a real life experience, like as if like you are standing there. Yeah. So this is it.
At this screen.
This is like a live thing which I'm doing right now.
I mean the TV screen.
Everything I added, like all these stuffs and these spaces where the spheres, the plans, and the curves around it, so you can like go in and see the stuff. Yes.
Furniture from.
Yeah. The furniture was different, but I just edited it a little bit to how I. Yeah. And this exterior space, I just want to like have it in outer space, so I just imported like a Mars outer rendering, so you are like, yeah, to get an experience that you're in Mars and stuff.
Any questions?
The avatar requirement about that.
Is that it is as like if you speak, it just gets the. It is like a meeting space overall. So if I'm here and you're in some other space, it just gives the voice to them. So if you speak, the avatar also like speaks. It kind of like moves its mouth like to yeah, to duplicate our voice. So it's just a thing like that. Yeah.
Wow.
It is like it just moves with the frequency. If you like give a higher noise, it'll just open wider.
Thank you. You wanna present your work? Yeah.
Ooh, teacher share. Feel powerful.
In general. Not.
Oh, back that. Okay. Okay. Do I need to be in a screen somewhere? Okay. Okay. I did virtual reality. Originally, I had it paired with digital twin, but I decided to back that off just because I realized how complicated virtual reality is on top of trying to tailor it with another program. Yes, I'm not gonna sit through here. So, basically, very brief, or the core of the research was to use virtual reality in the architectural design process, more specifically on how we can improve human safety in the built environment. So when that comes to, possible evacuation plans, new employees, you could train them on how to evacuate a building very quickly. Emergency responder training when it comes to police or firefighters responding to a scene, or
evaluation, you can train engineers to spot specific elements in a building that's been damaged to determine if the building is safe to enter or use, or if you should avoid accessing the building at all. Again, I was looking at a possible expansion on this research with digital twin, but decided to back it down just because VR itself is very complicated to use. Quick definition: virtual reality is just a computer modeling of a simulated 3D environment. It allows you to interact with generated images, objects, or even effects. You can move around a space or possibly interact with others. Right now, this is most commonly achieved by using, like, say, goggles and a handset that allow you both to see and environment. But there are steps or additional devices that you can use, such as a stationary treadmill that lets you actually run and walk within an environment while keeping your physical body stationary. A body scan increases the number of data collection points so that it can actually accurately model your own body in the VR environment. And there are other devices that are more niche. Currently, there is touch is the next main addition to VR. So right now, it's mostly visual and hearing, as well as interactive hand commands. But touch has been simulated and is slowly being interworked. So it is now the basic version of VR is to have touch and feeling integrated. I've said that a lot better. To do VR, I was utilizing the Unreal Engine, which is a gaming engine developed back in 1998. For the most part, it was originally used by game developers to create entertainment and video games, but has slowly branched out, and because it's so modular and accessible, it is now being used by architectural designers, as well as film, TV crews, and it is a very broad program that is very accessible. Here is a sample I made to simulate fire happening in a building. Ignore my panic clicking around. I didn't know how to zoom in. So this was a building I imported into Unreal, and I added fire effects. If we had volume, you'd hear explosions going on in the background to simulate like fire extinguishers going off or gas cans. I added a level of fog to the entire site to simulate wind blowing dust and debris out. Fire's mostly concentrated on the upper floors, but you can see it does take an effect. You can see it happening through the windows. Again, the idea of a simulation like this is to help either emergency responders or, say, you're a homeowner and you're trying to figure out what you need to do or how you need to escape your home. I did want to simulate the interior environments, but I ran into issues with bounding boxes and eventually had to back off that idea. Research I did so far. Come on now, there we go. There is I was shocked by how many fields are actually using VR right now. Entertainment is the one everyone's familiar with when it comes to video games or fun or watching movies and such. But healthcare is a big adopter. There's a company in Chicago that allows surgeons to operate using VR and operate surgeries across the country. And they've tripled their business since 2020. Safety training is a big one, especially when it comes to heavy construction equipment, how to operate it. And then a really big one was, or one of the most common is firefighter training, which was what initially prompted this research field. A lot of fire departments actually are trying to use VR, but because it does not simulate the touch, the stress, the smoke of an actual fire, right now it's seen as a supplementary and useful tool, but not a key component that they need to move forward. So as VR starts to integrate touch a bit more, we might see that be more actively adopted by emergency responders. Final conclusions is that VR is a useful tool. It is slowly making its way, similar to AI, into everyday life and into the various professional fields. But it's moving at a very slow pace just because it is still kind of seen as a auxiliary or extra feature rather than something that can be used as a main tool. As discussed before, most fields see some use in it, but because of its limited touch and other sensory inputs right now, it's seen as not as useful as being in the field or on site. And one of the main issues I found with mining or mining, with construction, with firefighters, is that they all seem to lack a common standardization when it comes to their profession. So even if they get a VR equipment and have someone trained to use it, there are no standardized scenarios that they can say, okay, this will train you how to do this. Everything is either made in-house or they find one that was made by somebody who did it for a hobby or did it for fun. It was not a dedicated field or made by a safety professional for training. So, any questions?
We have the gloves, right? The
Yes.
side of firefighter.
Yes, those are making their way through, and they do exist. But right now, they're still early phase and they're very expensive.
Yeah, I'm having a conversation with the local company. Maybe I will try some meetings.
I'd be okay with that.
Yeah, that's really gloves. All right, thank you. Let's move on. I think based on order, the next one is whoever in AI. Are you the only one? Okay. All right. That's good. Okay, where's the Teams? Yes, Teams. Just retype Teams. Okay, this.
It's not up in here.
It's already there. It's just being hidden. It's just a function.
All right, so for my presentation, I'll be going over Stable Diffusion. I was testing Stable Diffusion and kind of comparing how generative AI can interpret actual text prompts from the architects and kind of see how generative AI comes up with the same designs that humans came up with based on the same text prompts. So to start, so this research just proposes like a comparative analysis of architectural designs created by generative AI models against those created by human architects, and by using textual descriptions from real-world architectural projects as inputs for the text prompts in generative AI. This seeks to identify differences in design interpretation, architectural language, and alignment with the original intent. Let's get that. And so for this, I just started by finding like a variety of architectural project types. And I used the project descriptions provided by the architect as the text to image prompts. And then I compared the results of each to the actual images of the projects. And then at the end, I'm going to analyze the strengths and weaknesses of Stable Diffusion's interpretations and determine in which context it could be the most useful. So for the first one, I wanted to compare like a lesser known project to a more well-known project and compare the quality of the resulting images to kind of test how Stable Diffusion pulls the data that's already present and how well that can help it produce the images. So for my first one, I chose One River North by Mad Architects, and I input some of the architect's project description into the text to image. And this is the image of the actual building. And then this was the AI interpretation. So this one, as you can see, didn't do the greatest job, but it was a very like unique building. So I think it just struggled a little bit to comprehend the description. And the second one is a more well-known project. I used The Glass House by Philip Johnson. And then this is obviously the actual building, and then here is AI interpretation. It did overall a pretty good job, although still slightly off.
And I think one of the reasons for this was that in the actual description of the project, it used a reference project. So it said it was inspired by Mies van der Rohe, and I think that kind of brought more information that I could draw from to come up with those images. And so for the second one, I wanted to compare kind of parametric and more simplistic or rectilinear projects and kind of see what it could handle better. So the first one I did The Nest by Herzog and Demiron, and put the description in the text to image. And obviously this is the existing building. And then this is the AI generated version. And some of the images were pretty close to the actual design. Some were a little more off, but overall did a pretty good job there. And the next one I did was the Church of Light by Tado Ando. So it's a very minimalistic design. And this obviously is the existing building. And this is the AI interpretation. And again, it did a pretty good job for this one as well. So it was kind of hard to tell which one it could do more accurately since it did both fairly well. And so for the third study, I wanted to kind of test how well it could interpret like interior architecture descriptions. So for this, I used the Guggenheim Museum in New York City and a residential project that's located in Australia. So this first one, I input the project description. This is obviously the actual building's interior, and this is what it came up with. And it did it pretty well overall. I think if it had more information on maybe like the number of floors or something like that, it would have been really accurate. And then this was the more residential small scale project that I used. And this is the architect's actual interpretation, and this was the AI interpretation. And this one was also pretty close. So I think that could go to show that if you're working in a residential architecture firm, you could definitely use this to generate initial design ideas. And then for the last study, this one I kind of did more for fun. I used my own studio project to kind of see if it would have changed my outcome for my studio project. So I input my own project description in to see what it would come up with. And this was my actual design here. And then this is what it came up with. So quite a bit different, but I definitely think it could have been useful during the preliminary brainstorming phase. But I definitely think it could have also sped up my design process as well.
Possible we can talk about that design instead of draw. AI could help to formulate some ideas.
Mm-hmm.
How do you think about the name of the architects? Does it really be a big factor? I imagine Philip Johnson has hundreds of references.
Yeah, so in the descriptions, I never mentioned, I would just take out the name of the architect, so it didn't have that information. Yeah.
So let's move on to the digital heritage. It's just me. I'm the only one. Okay. Yes, the two of you. Okay, so maybe three. The three of you. Yeah.
Oh, don't want to do that. All right. I can't do like a full screen on this, can I? That's good. All right. So I did capturing digital heritage with iRhino 3D. Oh, gotcha. So scanning an object. Object scanning uses a combination of photos and LiDAR points for model capture. It is best to perform this task in a well-lit environment. Shadows on objects can cause loss of image capture. Reflective glass and polished surfaces can also result in poor outcomes. And once you're ready and you've got your object, you go ahead and just click the option Object and using camera and LiDAR. and then startup. So once object is visible, the device will start gathering data. It's not actually processing data yet, but it's starting to gather it. So walk 360 degrees around your object. This is a good way to also tell if you have a clear path around your object, because you're going to have to make 3 or 4 passes. Ensure the object is on a flat, non-reflective surface. And once you're ready, press continue. So digital fencing. So there will be a bounding box around your object that is determined by the program, and physically move your device closer to the object to adjust these points, because they are kind of difficult to grab. And you can also go closer and adjust the rotation. While it was really simple for this object, for something like a car or a person, you have to really get in detail and make sure that this is done, because this first step sets up the entire project, because it's creating a bounding box, deleting any unwanted LiDAR points that are outside of that box. So you're going to want to press Start Capture. Here you can see its capture is done in 3 stages. One is at holding your device at a 90-degree angle, one at a 45, and one at 135. So this gets a middle, high, and low point of perspective. And it starts creating this digital model up in the like above your plant or whatever your object you're scanning, showing your progress of how much you've scanned. If you notice, some areas aren't being filled with little dots of color that correspond to the actual object. You can supply additional photos by pressing this little button in the bottom right corner. Typically, that's best for really complex shapes. But then you press Process. The processing data portion really doesn't take too long. It says that like on the device, it says about 8 minutes. But in reality, it takes like 1.5 minutes. And then you don't have to do anything. It automatically will stitch the meshes and whatnot together, and create your model will be generated. So then the mesh object is placed in the iRhino 3D software. You can orbit it, you can zoom in and whatnot. And if you have holes in your mesh, like I do here, you can repair them in Rhino 7 or 8 on your desktop. But after you do a repair, you will lose the texture color. It will get all messed up. So better off just rescanning it and making sure that in those areas that you did lose a lot of detail, to just do that manual photo portion of those. And then once you're ready, you can actually turn on the AR feature. So we're looking at an augmented reality view. So now you can see it. I placed the plant beside the other plant, and they're pretty difficult to differentiate from each other. They're the same scale, same color. Lighting is different, but that also changes depending on the environment. And then after this, you can actually import this into your BIM softwares, or you can also place it into hyperspace, where it can be viewed forever. All right, and then so the other option is scanning a room. You can do that by just selecting that room. Same process where you want it to be well lit and whatnot. First off, you do a scan, and it usually takes a couple seconds to calibrate the device, but you want to orbit around your room and do that very slowly. It's important to also stop every once in a while and let data be caught up and captured. But it actually creates an AR outline of all of your objects as you're scanning your room. So you should notice that walls, windows, and furniture are all having these bounding boxes created around them. And in your bottom portion, the model is actually being generated. So whatever's generated in this little like bound and these like just random boxes almost, whatever's generated there is actually what is created in your end poly surfaces and whatnot. Right. And it's documenting all of your wall angles, heights, and whatnot. If there's an odd room geometry, like I have in my room, this weird vault and this like angle where the roof is, ceiling conditions are not captured by the software, but it is capturing the wall heights and dimensions, so you can easily just put in a poly surface there and it's going to know the angle and whatnot. Just you need the overall height of your ceiling. And then once you have scanned everything and you look in your bottom box here and it looks all correct, you'll press done in the top right corner. Then it starts processing it. You can see here it created automatically a floor plan. It has all of the dimensions of my room and the objects of my room, all dimensioned in detail, and you can just view it on the scan, and it records everything down to a 1/2 inch accuracy, which is nice. And then the massing model. So it creates, of course, a massing model. You can see here it's just the exterior sort of envelope of my upstairs. And then you can, of course, adjust these layers and just sort of change your view and whatnot. And it places each object on its own layer, which is very nice. So you can see here, I turned the chair, the sink, the storage, the table, the television. I turned walls off, turned annotations off. And you can see everything, my bed and whatnot. Like you can see all of the different objects in my room. And it automatically places them on a different layer with a different color, which is really nice. While this tool for Rhino iRhino 3D is great for like personal use and whatnot, in a professional realm, it would not be it's not accurate enough, and the technology that is accurate enough to use in like our type of architecture field is around $100,000 that they'd have to invest. So that's a very like company oriented or school oriented thing. And lastly, these are some of the scans that I was able to capture, and all of these can be placed into hyperspace, which is nice, and viewed forever. And so capture the world today so we can see it tomorrow.
Like it has both isolated mesh for objects, also very clean on the surface for viewing.
Thank you.
What kind of phone you use? I just use my iPad. Okay, so it has a DAX panel. Yeah, we've got a LiDAR scanner. Yeah. So that's a Pro, I think. Yeah, it has to have a LiDAR scanner. No, that's all. Just close and go back. I think it only works now. That's right. With iRhino.
Okay, so for my project, I was evaluating different smartphone applications for 3D modeling. I wanted to choose apps that were free to use so that they were accessible for students. A little bit of background. These apps use several different kinds of technologies. LiDAR, which is light detection and ranging, remote sensing technology that uses laser light pulses to measure distances and create three-dimensional models. Photogrammetry uses two-dimensional images to create three-dimensional models. Gaussian splatting realistically renders three-dimensional volumetric reproductions out of points that reference position, color, size, and transparency. And NERFs, neural radiance fields, which create neural networks to construct three-dimensional models out of two-dimensional images. So the apps were evaluated, measured, and critiqued based on their performance in the following categories. The first one was user engagement. So I was evaluating customer ratings, in-app tutorial availability, and overall app aesthetics. Then accessibility, so the technology requirements, what kind of
phone is required to use these. No cost features and overall ease of use. And then the effectiveness, the accuracy, image quality, and production speed. So my methodology changed a little bit over the course of the project. So the original subject for my research project was a historic building. I fell asleep. Oh, sorry.
Come back.
Oh, better. Okay. So the original subject for my project was a building across from City Hall that I was using for my historic documentation course. Due to external circumstances, access to this building was limited and the project was adapted. So in order to get an accurate assessment of the apps, they were tested on a less historic site, the living room of a 1965 home, my living room. So the apps were tested at a few different scales. I only got to test them at small and medium, so objects and rooms. Then applications. So although there are a multitude of mobile modeling apps, I selected these 3 because they were free to use and had the functionalities that I was looking for. So the first app was Polycam. So this app uses Gaussian splatting, LiDAR scanning. It also has a photo mode, so you can submit an album full of photos. And I believe for the free version, it's up to 150 photos for photogrammetry. It offers in-app tutorials and has additional web resources. In order to use this app, you have to have an Android 8 or later or an iOS 17 or later because it uses the LiDAR scanning. Pricing options, so the basic plan, which includes a lot, is free, and then the Pro plan is $26.99 a month. The app ratings for this one were really high. On the Google Play Store, it had 4.2 stars with 19,000 reviews, and the Apple App Store had 4.7 stars with 35,000 reviews. So the pros of this app, there were numerous 3D generation options, lots of tutorials available. They can be exported into most 3D modeling rendering softwares. And there's a room mode, which creates a simplified room model in addition to the LiDAR mode. So when I scanned the room, it also created this kind of rudimentary room sketch showing where the windows and the doors are, and it even placed kind of generic furniture where the furniture was. So it even placed a TV and a little armchair and everything. Cons were I was unable to get the photo mode to work for this project, and the Pro plan is required to export certain model types. The LiDAR model took a long time, and it didn't have a very clear result. You can see the result up here. A lot of the furniture is distorted, the images in the back are distorted, and it probably took about 20 minutes to fully develop. And that was after scanning the entire room. It took me probably 15 minutes to scan the room and 20 minutes for it to develop. The next app I evaluated was Luma 3D. So this app features AI text to 3D generation, 3D asset generation, 3D asset generation, NERF generated 3D scenes and objects, and video to 3D asset generation. So this app focuses a lot on videos, generating videos from objects. So the operating system requirements are Android 9 or later, iOS 16 or later, and the pricing is completely free. There are no paid upgrades available, so the entire app is completely free. The app ratings on this one were a little bit lower. The Play Store only had 3.3 stars, and there's significantly less users. And then the Apple App Store had 4.6 stars. The pros of this app were the 3D scenes were very realistic. You almost can't tell the difference between
this 3D scene versus just a photo of the room. These are both 3D scenes of the room. It was very, very easy to learn and use. It was quick and effective free AI 3D asset generation, completely free 3D models from videos. The cons were it took the longest time to generate these 3D scenes and assets, and there are limited scanning options. The last one I tried was Scaniverse. So this features Gaussian splatting and a map of local 3D models. The operating system requirements are a little lower, so Android 7 or later and iOS 14 or later, and this app was also free. The Google Play Store had 3.5 stars and only 101 reviews. The Apple App Store had 4.8 stars and nearly 10,000 reviews. So pros to this app, it was easy to use. It had a very clean appearance to the app design. There were a lot of cons for this one, though. It took longer to capture the scene. The objects in the final mesh were deformed, and there weren't very many options. So this was one of the captures that I got of the building from the beginning, the historic building. And it did not scan it well at all. And then the living room scan turned out very poor. I will say another pro for this app, though, is if you 3D scan different statues and stuff, they will reimburse you. So there's a perk that way. So conclusion, out of the 3 programs, I would be the least likely to use Scaniverse again. Both Polycam and Luma 3D have their own individual positive features. I would say the best for large 3D objects was Polycam because it also exported that room model. It was overall the quickest and easiest app to use. It had a lot of, but they weren't very needed. The results turned out well overall, and the free version offered lots of options. Best for small 3D objects, I'd say, is Luma 3D. The presentations are, Luma 3D had the AI asset generation, which was really helpful. You can type in a prompt and it'll generate a 3D asset for you. And the room model also turned out very realistic. Yes. No, I didn't have time for that. Have you tried it?
Yes, and it was unsuccessful. And I feel like if the interest just gonna just out of our data, and it could not create a scene as I would like. I want to ask about one thing in your presentation. The Puri can set up it up.
Yeah, to get that room.
How many photos?
I used the LiDAR mode.
So how many?
It didn't take photos, it just scanned. So it does a, I should have included photos of this, but as you scan, so the room shows as like blue, and as you scan, it shows the room itself. Yeah.
So I think if I have a furniture, Luma would be a good choice.
Yeah.
Good. Thank you. Yes. Who else is in the digital heritage? We are the last one. Is the platform?
Yeah.
Close. I checked real quick. I just want to make sure I'm recording. I think I did. Just like sometimes you forgot if you close your door.
Yeah.
Yes.
Okay, I think it's loading. Why it's taking so long? Okay. So my track was digital heritage. Just a little bit of background on my process. I have never used photogrammetry before. I didn't even know like what it was. So I wanted it to be really accessible. So I tried all of the phone applications for photogrammetry. A few of the ones that I tried were like the Rhino one, the Polycam, Reality Capture, but my phone doesn't have LiDAR. And I noticed that like a lot of people's phones don't have LiDAR. So that was a big priority in like which works the best. So my goal with this project was to create a tutorial for my peers that don't know what photogrammetry is, that like didn't take a class to understand what it was. Like I would have no idea what it was if I didn't take this class. So just kind of raising awareness about digital heritage and photogrammetry was like one of my main goals of this project. So after testing a bunch of softwares, I decided that Polycam was the best one, just because you do get 150 free images. You can do a 7-day free trial, which if you know you have a big project coming up that you want to like have unlimited images for, you can time that really well. It doesn't require LiDAR, and for what I was trying to model, which was the exterior of a historic church, it was really accessible because it works well for larger scale models. So just starting out testing like smaller objects. This was also the only app that I could get like to successfully like capture objects. Everything else, like my images weren't connecting, and it was really difficult. So this is my first successful model, and then trying something more architectural. It was my second architectural model. And then moving on to like the actual facade that I'm documenting. I wanted to do the church, St. George Parish Newman Center, just because it's a really recognizable church. Everybody passes it on their way to school. And it's very complex. Like the facade has a lot of like detail and depth. So I think it would be good. This is my captured facade. It works out a lot better than I thought because I was just on the ground. So this facade was captured with the 150 free images. You can see at the like top of the dome, it gets a little bit funky because I'm not like in the air actually capturing that. I was just on the ground walking around. But it turned out really well. I have better images in my like final one, but for this purposes, is this a video? No. Okay. I also tried to do the free version to capture like 3 sides of the facade. It was really cold outside, so we didn't spend that much time capturing it. So there are like holes in the model. If I spent more time, it would have been better, but it was actually really easy to like walk around and capture the facade. And surprisingly like straightforward. And I think Polycam is the best app to do that. So after this, I created a tutorial, basically like screen recording how I did this and like voiced over it. And then I tested that with my peers, and I can pull that up. So this is that captured facade. And then the tutorial. And then I had someone who like isn't even in architecture, like he has no idea what any of this was because I wanted it to be very like comprehensive. He created a model of a shoe, and it turned out a lot better than I thought because he's never used like any kind of software like this before. And it was really straightforward, and I like going through this process with my like friends trying to create a tutorial that like people would understand was really interesting. And I like raised awareness about this. Like one of my friends in interior design ended up using photogrammetry for like one of her projects, and it was really cool to kind of like spread the knowledge, if that makes any sense. But yeah, so I would say it was pretty successful, and that was my project.
Questions?
Yeah.
I want to see the next slide.
Yeah.
So this is like you just combine two images. It's not an object, but
It is an object. I don't have the like video. I have it on my phone if you want to see it, but it's a whole mesh of three sides of a building, of the actual church. And it has a lot of detail, but it's
then it's an object. So I can see the roof.
yeah, since I was on the ground, like I didn't have a drone or anything to get that like higher elevation. So since you're just like taking pictures, walking around, I'm only at like 5'7", so I can't like go up to capture those images. But if you had like a drone or something that you could like actually get that, because it's only as smart as the images that you like put into the program.
Yes, that's my question.
Yeah.
You told me that so why I see the possibility. I mean, I see two roofs there. Are they higher any taller than you or?
Yeah, so you can see the hole right here. So what it does is it like infers. So it could see that there was a roof structure, and that's what that like little dark blob is. And it kind of like, and you can see here, it just kind of like fills in the gaps with like a bad version of what it should be. But this, I can show you the like actual model if it would be clearer, but it's quite literally just like a surface. Like it's just like an empty mesh.
And you did what for it?
Mhm. I did it with the free trial though, with more than just 150 pictures. I think this was like 370 pictures. And then this one was 150.
By taking picture, not scanning like.
Yeah, I did the auto version of the capture thing, so it like automatically takes pictures as you like walk around, so you can make sure they mesh together. Yeah.
Okay, I have experience.
You can watch the tutorial too, because I go through like exactly like how I did this. Yeah.
My other question is, can I see the?
Yeah. It's like bad quality lighting, but.
And Polycam, I remember that Polycam can create rapid model into drawing.
No, I'm not sure what. In Polycam, like if you use, when you go to export it, and I talk about this in the tutorial, it like automatically groups file types into like what's the best software you're using. So like I use Rhino, so I click the like Rhino tab, and then it tells you like what file types you should export it as.
Right.
And there's like I don't know, I think there's like 20 different file types at least. Yeah, it's in the tutorial too.
3D.
Mm-hmm. Yeah, there's a couple. You can do meshes or point clouds. It just depends on like the quality of model and like if you want textures and stuff like that.
If you don't mind,
I'll wrap it up.
Both
Yeah. Yeah, I'll do both versions.
I think that's all digital heritage. Let's move on to digital twin. Okay, so I have three of you, right? Digital twin. Right? I use
this one. Okay.
Okay, so I did my presentation on digital twins, and it's about unlocking the potential for small business success utilizing digital twins. So first off, what is a digital twin? It's a virtual replica of a physical object, system, or process that uses real-time data to simulate, monitor, and optimize its performance. So quickly, what are the advantages of a digital twin? So for the sake of this research, I looked into using a digital twin to enhance decision making, optimize cost savings, improve efficiency, and improve sustainability as well. The ways it can do this is help simulate, and it can help businesses predict outcomes, and use it to make more informed decisions. Same thing with reducing risks and eliminating trial and error. It gives you an ability to test things before you implement it into your business. Again, efficiency is another thing that is key to this. And then sustainability, it can help minimize waste through simulations and trying something before you do it. So how does a digital twin work? They work by 5 points, but 4. So input, processing, storage, output, and then also re-input, or like a continuous loop. And so it collects the data via sensors or commands or user input, and then it processes it using its CPUs, and it stores it. So examples of these are Autodesk Tandem, Matterport, Unreal Engine, and Microsoft Azure. And so for this research proposal, I looked into Autodesk Tandem, and the key features of this were that it was seamless BIM integration, and I was using Revit, data centralization, real-time insights, and then the ability to collaborate with other people as well. Is really easy through the BIM softwares in Autodesk. So for the research studies, I just looked into, again, like how can they streamline routine operations using a digital twin in business, and how can this help increase the ROI of a business. So the aim of the research project was to explore the integration of digital twin technologies within a business, to see how adopting digital twins could improve a business performance, optimize routine operations, cut costs, and add value in management and operation of a company. So for the first step, I created a floor plan, as you can see here, and then extruded it and made sure to tag all the elements that I wanted to get identified within the Autodesk Tandem model. Made sure to model all the electrical, plumbing fixtures and casework as well. And then step 2 was to import it into Autodesk Tandem. So once you import it into Autodesk Tandem, this is what you get. You get your full BIM model in there, and it reads everything, and it comes in pretty correct right away, which is one of the key traits of Autodesk Tandem is its seamless BIM integration. So the next thing that you can use within Autodesk Tandem, which is interesting for diagramming purposes as of like an architect, or just getting an understanding of like what all you own as a business owner. It's an easy way to just lay out your floor plans and quickly see like, okay, here is the electrical fixtures, here's where they're located, same with plumbing or casework, and all how those systems connect. So you can go in and set systems, which will set up and group different items or caseworks within the Autodesk Tandem, and it can auto-populate for you a list and chart and itemize all these, where you could go in and eventually add like inventory or whatever you would want to utilize through your business. So it's like a digital kitchen almost. So then looking into the inventory and how this could help a business. So through Revit, you can implement and add your own custom parameters, which then appear in Autodesk Tandem. And so as a business owner, you could go in and just update the inventory counts and honestly whatever you wanted to add to the families and the equipment. And so that way anyone that has access to the model gets real-time updates and can see it. And again, the whole idea of this is that you could go further and use sensors, and it would all be real-time updating for businesses, and as well as people looking to invest into them. So after looking at Autodesk Tandem, this was the best in my opinion for architectural reasons and just looking at it as like a small business owner. But there are other digital twins out there that could be good for a variety of different interests. So another thing I used during my co-ops a lot, and in the architecture space, but not necessarily for business owners, would be like Matterport digital twin, and this does a 3D space capture, and it uses cameras, and then you can create your own walkthroughs. And an advantage of this is its seamless BIM integration, which is similar to Autodesk Tandem. So that's why I included this. But it provides way different capabilities. So as you can see here, here's like the map that you scan in your whole building, kind of similar to digital heritage, but at a massive scale. And then we've done this with clients where then you can go in and pick spots to look, and then you render them. And it's a really good way of creating like a 3D, a digital twin, but in a different way. And then finally, Unreal Engine is another one that you could utilize for a digital twin. This one really has high quality visuals. So if you wanted like almost realistic, really real images, this would be a really good digital twin to use for that. And it also enables real-time user interaction through digital twins and simulations and walkthroughs, similar to Matterport. But this one is a little different because it's not directly integratable with Revit. You have to go around and use a Datasmith plugin for it to work. Or like use another platform which is stronger in BIM, like Azure for digital twins. So it's you kind of need assistance from other programs to really utilize it in the same aspect as Autodesk Tandem. And here are just some images of what you can create, same kind of thing where you can get a real life feel of what it is and visualize it through a digital twin. And then finally, Microsoft Azure. This one is a little different than all of them, but it is right now being used in a lot of industries like healthcare, manufacturing, retail, government, and a lot more. Even education, which I thought was very interesting. And it helps gain insights that drive better products, optimize operations, and deliver breakthrough experiences. And it uses these IoT devices similar to AR and VR and cloud services for dynamic wide monitoring. And again, another advantage of this is its direct compatibility with Autodesk BIM technologies, similar to, again, Autodesk Tandem, so trying to give you a variety of digital twins. And then finally, here are just some images of what Microsoft Azure can create. So it's a really similar software to Autodesk Tandem, but I think Autodesk Tandem at this point is a little further ahead, even though Microsoft is integrated, or Azure has been integrated into Microsoft. But so they're a little competitive, but they offer different options. And that's it.
To compare multiple solutions. Yeah, that Tandem is multi-graded. Revit is from Autodesk.
Yeah.
Job.
Thank you.
All right. Yeah. Ready?
Sir, friend, I can do it like this. So I also did digital twin, but I took a similar but a little different route. So what is digital twin? It's a technology that is starting to really change the architecture, engineering, and construction industry. And for this presentation, I looked into Autodesk Tandem, GE Verona, and OpenUSD. But yeah, pretty much the goal is to just enhance project efficiency in the management of buildings. And then this is a quote I took from NAP in my E1. It's just pretty much saying a digital twin is a set of virtual information that mimics a structure and the context of a system. So who benefits from having a digital twin model? It depends almost, because digital twin can be used for various things. But for this sake, architects and designers, construction professionals, engineers. How do I get this up? Okay. But yeah, pretty much for architects and designers, it'll enhance design visualization, help communicate your design easier, allow you to iterate and test certain things inside the program.
And for construction professionals, you know, it can help project management, managing the site, and risk mitigation for people working on the site, so enhancing safety. Then engineers, you know, you're really getting an ease for the system integration because you start to see it, which we'll dive into later on. But yeah, performance monitoring, HVAC, plumbing, things like that. There it goes. It just disappeared. Yeah, I don't know why it was taking a minute. So how does it work? Aaron touched on it, and I'm sure the rest of the people that will do digital twin will also touch on it. But pretty much it collects data through sensors in the actual space and in your BIM model and the data you provide. So it'll process that data and integrate analytics. This is from Azure. It's yeah. So pros and cons, just enhanced design visuals. We kind of touched on it, but the cons are pretty much high initial costs for a medium size or small business. They might not really be able to uphold paying for something like this. There's a complexity to the maintenance and all the challenges that obviously it presents in a new software. So I kind of just touched on it, but yeah, the effect on companies in a beneficial way, you can save money on maintenance and energy over time. Obviously, you have to recoup that cost, but better use for space. You know, you can organize it better, solve your problems faster, and help you with long-term planning as an overall. So GE Verona, these are some pictures from their website. GE Verona you need to pay for, and the trial was a large file, but pretty much GE Verona has all these different data sets, and from the BIM model you import, it'll start to pull this type of data, and you can edit and monitor it based on all these sliders and things like that. OpenUSD is more or less, I don't want to call it a rendering software, but it's definitely the digital twin for a large scale thing. But Pixar uses it. It's created by Pixar, and they do a lot of like animation with it. So it's really strong in that regard. But it creates a digital twin of, you know, a space you model for whatever you're animating. And also it can be used in factories and such. Like here's some images from it being used in Amazon and BMW and them managing how they appear and things like that. So Autodesk Tandem was really my focus. I started here, and I'll elaborate on it in a second, but I created this Revit model to see, you know, the capabilities, and I realized with our time constraint, it might be easier to, instead of putting all these systems in here, look at an example they had, and that actually really helped. After doing all this, you know, here's some of my process work. You can test a twin, build a twin, and so I built a twin originally, and you can see all the systems, the levels, the spaces, the rooms, and codes that come up in this filter property tab. But when you dive into it and you open a sample model, it really starts to create more of an in-depth view. So here's a selection of all the levels from the sample model. This is the garage, and then you can select the site, things like that. And you can go in the properties and click spaces. And here I just clicked the major corridors for circulation. So this is like all the stair course. And then this is structural base systems. So it's showing the foundation of this building. And then, of course, the building systems that are really benefiting from Autodesk Tandem. So you can see the hot and cold water. This is also the sanitary lines, or actually that's this one. And then this is the air and HVAC systems. So when you do stuff like this in Revit or a BIM software, for an engineer or a construction company that is building these things and having this at your leisure almost on an iPad or wherever you can access Autodesk Tandem is really helpful in the construction process. And then just diving into more of the systems, you can select these systems, and these systems come with sensors when you install them. And they report data back to Tandem. And so this is data that's coming from this sample twin, talking about the air quality and the temperature during the night and day, and this is a wider range and things like that. And then this is also a heat map that you can get from all the systems inside the building, and that comes from down here. I should have highlighted it, but there's this little button that you click, and you can click select heat map, and it'll show the heat for the overall building and different levels, and you can click level to level. So this is the base level, and then this is the top. So in conclusion, what are you using all these for? OpenUSD, I said earlier, is developed by Pixar, so it specializes in creation and animation. So it's a different style of digital twin for industries in like film, gaming, things like that. But it could definitely be used in the real world for, BMW and Amazon, like it was shown. It's very powerful and capable. But for our level, I think if I was to choose OpenUSD, that would be the route I would take. It was for gaming or simulation or things like that. GE Verona is a lot more sophisticated for industrial systems. It grabs a lot more data that you can, control. And that's involves coding and things like that I obviously wasn't able to get into. But for our sake in this course and as architects or pursuing architects, Autodesk Tandem is very strong and robust for everything it gives you. And it's, pretty easy to use if you're comfortable in Revit and modeling those systems and softwares, because it's pretty much just a couple clicks and you import it in if you've done everything right in Revit, and, to really aid the construction process. And one of those things, if you're a small business or small architecture firm, if you could provide it, it could definitely be an extra cost that you could coop up. So, yeah.
Glad you pick up the other two platforms and we compare. The also
So for my research, it started with digital twin, and I got interested in the usage of smart materials and wanted to do research and a little bit of a proposal for what could be done with smart materials and their integration to digital twin. So the purpose is to explore how integrating smart materials with digital twins can help improve building energy performance as well as safety. And the concerns that I wanted to focus on is the importance of energy efficiency as well as adaptability for real-time emergencies and customability inside the building. We've been through this before, but for digital twin, it's just a digital representation that just showcases and mirrors real-time performances and real systems and enables monitoring and simulation for optimization throughout the building that enhances function and overall safety. And it uses real-time monitoring, simulation predictions, and just lets you know like what if scenarios of using HVAC systems or how efficient or safe environments can be. Helps automate and adjust systems as well as help with life cycle management and helps predict issues that could potentially arise within the building. So the methodology going forward was the analysis of adaptation facade system and integrating smart material to the development of a digital twin model, and then testing for energy efficiency and the response for an emergency. And some of the tools that could be used throughout this is Grasshopper, Rhino, BIM tools, and IoT sensors, as well as like some of the ideas of smart materials that I was thinking of is possibly like electrochromatic glass, phase change materials, and so on site. And this is where I started to look at the application of what these smart materials can do, and smart materials in this situation, meaning more dynamic shading, kinetic facades, pixel glazing, liquid infills. So how can smart materials be paired with a digital model and enhance a building? It can provide protective and preventative informants, aid the user and control experience to ensure safety throughout the building, and assist in maintenance, durability, and life cycle of a building, detecting any issues as well. and provide smart shading and adaptive lighting and provide feedback in the building systems as well. And here's like a unit and showcasing what that can look like outside of a building. So the units can be used in simulated and real events with the BIM models to run and analyze what solar usage and adapting to shading for individual rooms and like helping with overall energy consumption and temperature throughout the building. And here's just a modeled unit that can be imported into like a digital twin model that can help show where each individual panel is and how that can rotate, and each have like an ion sensor that can go back to the cloud digital model and help to analyze that and predict temperature patterns and solar patterns that can help with energy efficiency. And this is basically like what that could look like in an application setting. So you could have controlled devices within each room that can help you open and close different systems, kind of overriding what would be potentially just an automated adaptive solar moving to help shade. So allowing you for different scenarios to open and close and promote more lighting. And what that would look like is energy efficiency. So you can see dips where that could have been used for potentially different uses and going against what would be the typical shading. And just more about the live analysis of what that looks like in the digital twin model, combined with everything else systematically. So using larger hubs like One Creative Environments allows for users to receive like in-depth analysis from those IoT sensors and provide information of all the systems within the building. And with that, using those shading devices, you can also run simulations to let see what the building would be using for as far as energy consumption and shading with heat maps. And so then that's where it gets into enhancing the experience within the building. So using these smart materials as well with like the glass and lighting can help promote like unique visual settings as well that can be controlled by users for individual settings, depending on what the usage scenario could be like. And getting into the usage of those smart materials in a preventative setting with integrating those smart systems as well as lighting sensors and detection, it is able to use embedded sensors to monitor different conditions and structural stresses, temperatures, vibrations, and relay that information like instantly back to the overall cloud hub model and digital twin model, and combine them to help create emergency routes and use the data that's been collected throughout the sensors to provide safe passage and help safety throughout the building. And what that could look like. So this was just a AI generated image showcasing with what my prompt would be for these lighting systems and materials. So if there was any sort of emergency scenario, how different lights, screens in the building could be used that were part of the cloud system to showcase and help people evacuate the building safely and be able to monitor that and just create safer and more adaptable buildings. And you can also, with having that 3D model in there as well, have tests for how quickly people can evacuate. So that's where it begins to integrate with VR and how people, visual triggers and sensors that can let you know where to go throughout a building and how that can adapt for different places for if there were fires, earthquakes, or natural disasters, how the building can respond and what the response time can be from people who were given visual or audio prompts throughout the building, and what those results could be from the smart materials as well. So this is just a chart showing how those shading devices can help reduce energy consumption overall and help with cooling throughout the building and just sustained energy consumption. And here are my sources.
I'd like to suggest in a good research in the final, you can optimize more on the two-way data exchange, right? So digital twin is not just collecting data from physical real world, but also pushing the data back.
Yeah.
And that is the point you have a smart material or the kinetic shading device or the egress sense will be actually computed in the digital form first, then kind of control the operation, right, in the real one. So talk a little bit more on the two-way data exchange.
Okay. Will do. Thank you.
Good. Thank you. Cool. Let's move on. Last, not least. You got anyone else?
Okay, I did my project on the effect of the lighting design on the natural and built environment of UC's campus. So first, I start with the definition of light pollution, and it's, in a sense, when we create more light than is needed and it blocks out the natural sky or the dark skies, and it affects the environment, ourselves, and the animals that are around us. I start talking about photometry and how much light is actually needed for the human eye to see, as well as how much light is permitted, like in regulation services, to know how much light is safe, and then how much light is actually produced in cities. Here, OSHA notes that only about 500 lumens are recommended, and about 1,000 to 10,000 are used in the average street light. So my research question is, how can I use design to combat prevalent environmental issues that are present in my local environment? And so I look kind of at the different lights that UC has on its campus in the different areas, and seeing how they could be improved. So some negative effects that I can mention about how it affects animals is in certain areas where they have sea turtle births. Sea turtles are drawn to the nearest light source, which would typically be the moon, but because of light pollution, they're often drawn out into streets or out into different areas that are not safe for them because they assume that the brightest light is the moon. Human effects, it affects us in a lot of different ways, and from our sleep to our health, internally to our mental health, light pollution can affect all of these things. So the study conducted was using a light meter. This is a different light meter than the one I used, but it's just an example of how they work. This area here is what you hold close to the light or in the area that you'll be using it, and you can measure how many lumens or lux is being emitted from that light. And light pollution is also tracked by the Bortle scale, and that just ranks night skies from 1 to 9, I believe, and it shows completely saturated skies versus nice, clear, dark skies. And then who uses this information and how they use it. Going over just the brightest cities and the most notorious light pollution cities, and how my process, or where my process could be placed or done. This is a light map of Cincinnati. As you can see, the downtown area is the most polluted, and so that is where I would be focusing, or that's where I would focus in the future, but right now we're doing the UC campus. Some proposed solutions would be to use blackout lighting, which is taking a light fixture and just making sure the light is all being angled down to the ground. Using LED lights, amber lights, or motion sense lighting so that the light isn't on all night, it's only on when someone walks by. Some softwares that I use to calculate my data are AGI 32, which is a lighting software that works in tandem with Revit and Rhino, and you can import models into there and use IES files from different lighting companies like Vega, and place them in the model and then take them into AGI, and it measures exactly how much light that light emits, and it can be tweaked and altered as well. So these are some light selections from Vega that I felt fit the criteria. I went with whatever light emitted the least amount of lumens and also had that blacktop feature, meaning the light does not go above the actual fixture. One of the sites I selected was Burnett Woods. Another was Campus Green. Another, our Varsity Way. And finally, U Square Courtyard. So, Burnett Woods, this area here is what I selected, and I used that photometry app to just see what the brightest parts of the area were. And as you can see, the night sky is actually lighting up as one of the brightest spots, which is concerning. Same for Campus Green. And you can see these lights are an example of the negative lights, or what they told us not to use, because it does not have that top area. On our Varsity Way, they actually do have the blacktop lights, but they also have the stadium lights right behind it that are on, so that is affecting the area negatively. And then in U Square Courtyard, they have the blacktop lights as well, but then they also have a series of decorative lights. So my first model I created in Rhino, and I originally had all of the rendering things in there, but trying to bring it into AGI, it caused a lot of problems, so I just went with the base ground level. From then I brought it into AGI, brought this light into AGI as well, and placed them where the current lights are. So this is a rendered image from the AGI software. It also shows how many lumens were actually on the ground. It has calculation points here. And then this would be the pseudo image showing the brightest spots. This site is very wonky because bringing a complex curvy shape into AGI is what I found was the most difficult. The rest of the sites seem to work pretty well. And then this is a render of how my lights would look in that space, allowing you to see the sky. For Campus Green, I placed these garden lights all along the path. This was the site that currently has like 6 different types of lights, and the majority of them are not blacktop lights. So I replaced all of them with these garden lights, which are about bollard size, and placed them along the path. And then this is showing how bright that would be as well. And then here's a render of what that would look like. For this model, for our Varsity Way, I replaced the giant stadium lights with bollards as well, but a different kind of bollard. And you can see it lights the space, but not too much, like not